iPad to be able to draw what I'm talking about. So all I'm pointing at this point is just look at that coefficient on the right-hand side of the equation, 8 pi g over c to the 4. That's the key object, mathematical object that I'll be talking about, that I claim, along with Professor Keith Wanzer, who's on the faculty at Physics Department, Cal State Fullerton. I claim we can control that factor. By making it big, we can produce a strong gravitational field on the left-hand side using a small amount of energy, which is that TAB, or energy density, stress energy density. And that's how the Tic Tacs work. That's how all the UFOs work. They're low-power warp drive vehicles. So let's go on to the next slide. Okay, well, this is some numerical work showing why anti-gravity is so hard. Anti-gravity is so hard because it's very difficult to bend space-time. In fact, if you read the standard books about it, even like Jim Woodward's book, Making Starships or something like that, he says it takes like a Jupiter amount. You'd have to take the entire mass of the planet Jupiter and convert it into energy in order to get anything useful. And of course, that's impossible. And that's not what the Navy is seeing in these Tic Tacs. The Navy is seeing these things, buzzing them in restricted battle spaces, and they're hardly using any energy. So there's something that they're missing. There's something that the pundits are missing. Let's go on to the next slide. Okay, well, this is from, I just want to give a little credit to this guy, David Chester, who prepared these slides, actually, and he's a PhD in physics, theoretical physics, University of California, was an undergraduate at MIT. Let's go on to the next slide. Again, okay, this is more on the alternate views of the matter-gravity coupling, and I encourage anybody who's seriously interested in the subject on their own time to go through this slideshow. The slideshow is available. It'll be, you can look at it at your leisure, and also you feel free to send me email messages if you have questions later on by email. You know, this is difficult, complicated stuff, and we're doing the best we can. Okay, the space-time stiffness of vacuum. Using the speed of light in vacuum, you see it's 10 to the 43 newtons. That's a lot. That's too big. That's how stiff space-time is, using units of force, using the MKS system units of force. Okay, let's go on to the next slide. All right, let's skip. Okay, well, no, this is important. Okay. The key thing about general relativity is what are called geodesics. What's the simplest geodesic? In Euclidean geometry and in Newtonian non-relativistic physics, the geodesic of space-time is simply a particle moving in a straight line in flat space-time at constant speed without any acceleration. That's the geodesic for flat space-time, and it accords with our common sense notions. Now this gets generalized. This gets generalized in the curved space-time of general relativity, which is what happens. The geodesics are paths of what are called test particles. What is a test particle? A test particle is a mass where we can ignore that it's generating its own gravitational field. In other words, the mass is so small compared to, let's say, the mass of the Earth, that it's only the mass of the Earth whose gravitational field we have to consider. And what happens is any test particle that's neutral, there's no electromagnetic fields, there's no net electromagnetic charge or multipole moments, anything like that. So what will happen is that the test particle will move on what's called a time-like geodesic. And I'll get back to all this when I have my Apple iPad with my Apple Pencil. I can draw all this. Pardon the noise, that's a truck. And so the point is this, what about these geodesics? Well, when you're on a geodesic, you're weightless. Okay, well, a good example of a geodesic is the International Space Station orbiting the Earth, in free motion orbiting the Earth. They'll say circular elliptical orbits. And all the astronauts are weightless in there. They're floating around, or they have to tie themselves down or use magnetic boots. It's not like Space Odyssey, where we have a rotating thing with fake artificial gravity. But so the point is this: that if you're free floating, John Archibald Wheel likes to call it free floating on a geodesic rather than free falling. But when you're just drifting along on a geodesic, you're weightless. There's no G-force on you. Okay, but if you look at that space station, and it has centripetal acceleration relative to us. So it appears to be accelerating, but in fact, it's not really accelerating to the guys on board. So there are two ideas of acceleration that most people do not understand very well, including a lot of engineers who should know better, and even some physicists who should know better. In general relativity, we have what is called proper acceleration. That is the local G-force that a person feels. And in order to have G-force, you have to have a non-gravitational force. Generally, it'll just be the electromagnetic force has to act on some charges in the material, and it has to push the system off the natural time-like geodesic. Now, this is happening to us on Earth all the time. That's why we feel weight. The reason we feel weight, that we feel heavy, is because we are properly accelerating radially outward all the time. We're being pushed by the electromagnetic forces of the Earth, of the star that we're sitting on. We're accelerating outward, but we're accelerating outward without moving, obviously. We're stationary because space-time is curved. See, this is you see, if space-time is flat and you accelerate, you've got to move from one place to another. But when the space-time is curved due to gravitational field, you have to accelerate in order not to move at all. So this is a big thing that most people don't understand, okay? And this confuses everybody. It confuses a lot of people, especially confuses the military. It confuses Louis Elizondo. It confuses Christopher Mellon. It confuses Senator Marco Rubio. It confuses, maybe it may even confuse Bob Bigelow, I don't know. But it confuses a lot of people, and it's understandable. But now, let's go on to the next slide. Okay, well, this is, we'll come back to this later. Understanding Einstein's gravity field equation in general relativity, in a way, is no more difficult, if you look in the right way, no more difficult than understanding Ohm's law for simple electrical circuits. You know, a voltage, you apply a voltage to wires, you get a current to flow, and there's a resistor, and there's maybe a capacitor and an inductor, and you get an all that stuff. So as electrical circuit theory, you can understand by analogy. You understand by analogy what Einstein's field equation is. It's in terms of electrical circuit theory. There's an analogy there. Let's go on to the next slide. Okay, the Alcubierre warp drive. All right. Now you've seen this a lot. And this is a toy model. It's not realistic, really. There are things, wrong with it, but it just illustrates the idea. Now, if you look at this is if you look at see the reddish, the pink little lip underneath that plane there. Okay, that's called a gravity redshift, because space, when you have attractive gravity field, the three-dimensional space actually kind of contracts, and it causes a redshift. It's like spectral lines from radiations from atoms. They'll be shifted toward the red. Okay. Now in the back, so the nose. Imagine this to be like a flying saucer of some kind. So the red part is the nose of the craft. Say it's coming toward you. If you see a flying saucer that's coming toward you, there's going to be a gravity redshift. There's going to be a gravity redshift, which is going to be opposing the motional Doppler blue shift. Normally, if an object is moving fast toward you, any kind of waves coming from that object tend to get shifted to higher frequency. It's called blue shift. But because of this gravitational effect, in addition to the motional effect, it's gonna weaken the blue shift. So in warp drive, the gravitational redshift in front of the object, at the nose of the object, is going to weaken or counteract the motional blue shift. And likewise, in the rear, in the tail of the craft, where you normally would see a red shift, because moving away from you, you're going to see a blue shift. So anti-gravity, that's where space is expanding, see? And what's happening, the ship is just like surfing along, just freely floating on a geodesic. This is geodesic motion, zero G-force inside. The ship is controlling its own local time-like geodesic, and it's not feeling any G-force. I mean, it can, if you design it badly, you can have some G-force in there. But I'm talking about the optimal, the ideal, the ideal situation. So, but it's controlling its own geodesic. It's canceling out, say, the external gravitational field. It's overpowering the external gravitational field, and it's controlling, and it can change its motion. So when you see the UFO or the Tic Tac, it appears to be going at 20,000 miles an hour, and it necessarily makes a big right angle turn. And they say people like Kevin Knuth, who knows his special relativity, but he doesn't seem to understand general relativity that well. He says, well, you have impossible G-forces. Yeah, they are impossible G-forces if the thing is moving through space. If it's not warp drive, what you're seeing is impossible. But with warp drive, you're seeing exactly what you expect to see. So if you properly understand warp drive, there's no mystery on these motions, the high-speed motions with sudden changes, or the apparent the thing kind of disappears and it reappears somewhere else almost instantly. That's all easy to understand. It's exactly what you have in warp drive if you can control the gravitational field with small amounts of energy, which these things are obviously doing. That's an empirical fact. See, Nick, I hope you're listening to this. Saying, I'm trying to explain facts. I'm not doing this out of like I'm jerking off because of some string theory, 11-dimensional mathematical. I've smoked too much dope on mathematics. I mean, they're saying, what was it, Karl Marx or was it Lenin? Somebody said the opium, a religion is the opiate of the masses. Well, in this case, too much pure mathematics is the opiate of the theoretical physicists. There's too much around. I'm going, and let me say this again. Let me give a little history. About 50 years ago, and this is about the same time I met Nick Herbert, actually. About 50 years ago, all kinds of weird things happened. And it was the CIA, Central Intelligence Agency, and contractors and agents from the Central Intelligence Agency and the Defense Department, in particular a guy named George Koopman, who Nick knows very well. This is like when was this? Let's see, this was 1970, it's the end of 1975, right before the Esalen seminars that that I had. Gary Zukov came down. He wrote the Dancing Unruly Masters. Right before those seminars began, Saul Paul Sirag and I and Fred Allen Wolf, we were living in a apartment right across the street from the Grace Cathedral. The apartment was paid for by a woman named Jean Lanier, who was a close friend of Lawrence Rockefeller. It was actually Rockefeller money. Paying for this several flats. In fact, Brian Joseph, the Nobel Prize physicist, Brian Joseph stayed with us. He had just gotten married, I think, to his wife Carol. And he spent about a week with us, going down to see Hal Puthoff and Russell Targ and Brendan O'Regan and Edgar Mitchell. All these guys, testing Uri Geller and people like that. In any case. So I'm up there with, I think Saul Paul Sirag was there, and also Fred Allen Wolf, I think, was there. And we're in the main room, right, looking at the window. There's the Grace Cathedral right across the street from us on top of Nob Hill. And George takes out a bunch takes out a briefcase, and he opens them and said, "These are burglar tools." There's a CIA agent. You have to learn how to break into, how to open doors. And yeah, George used to play. He used to try to train us. Just said, well, look, if you're going to be a CIA agent, you have to have situational awareness. You go through all this stuff because we were very bad at it. You know, like trying to what color of clothing is that woman wearing? And you know, there's these training things, I guess, that they do at wherever their base is, Guantanamo, wherever the hell it is. Quantico, I guess that's the FBI. In any case, he'd like to play games. I was, you know, intelligence agent games with us. And, you know, we were pretty young. But in any case, so we're up there this one time, and George gets very serious and he says, there are two things the CIA wants you guys to figure out. Consciousness. This is the whole now, How the Hippie Saved Physics. David Kaiser's book talks about how does consciousness work? Why do they want about consciousness? What about consciousness? Because they want to control minds, right? I mean, this is, you know, MK Ultra. I could tell you a lot about MK Ultra too. And so how does consciousness work? And now when they say consciousness, I'm not talking Deepak Chopra, you know, enlightenment, Zen Buddhism. I'm not talking Nick Herbert's, you know, he plays his flute, you know, all that stuff goes into enlightenment. I mean, all that stuff is good. I have nothing against that stuff, you know, but that's not what George Cooper was saying. He wanted to know the physics of consciousness. He wanted to know what is there in matter that enables us to be conscious. That's, you know, the physics consciousness problem, the sort of thing that Hameroff is trying to work on with Penrose, right? That they want to know how to make machines that are conscious. And actually, Nick Herbert did write a good book about this. I forget. Yeah, he wrote a couple of books, but this book about mind links. I forget what it's called, The Mind, where Nick envisages all these kinds of machines that the CIA really and the intelligence agencies in general, and not just the CIA, it's the Russians, it's the Israelis. I could tell you a lot about that. That they want to know how to control consciousness. You know, obviously for non-lethal weapons, we have Colonel John Alexander, right, with his non-lethal weapons. Where I mean, why use a neutron bomb? Why use napalm? Why use any of these weapons that destroy property if we can just win a war by controlling the enemy's mind? Okay. Now, of course, we know I get a whole thing of sideways with, you know, with the CIA involved with that, and William Colby, the DCI, and what the Russians were doing, and Uri Geller and the Mossad. You know, that's a whole other aspect of what we're involved in here. Okay, and or the high strangeness factor. So in any case, so that was CIA and Defense Department. We were actually getting money from, not directly from the CIA. George's group, INS group, was a defense contractor, and we were getting money from the Army Tank Command and from the United States Air Force, and also, you know, from Rockefeller via Jean Lanier and her husband, Sidney Lanier. So in any case, they want to know how consciousness works. Then what's the second thing? That's what's important now, today, right? With UAP. How do flying saucers fly? They want to know how flying saucers fly. And those are the two things they want to know. And basically, that's what I've been working on for 50 years. And actually, even before 70 years, I go back because I think I met Phil Corso and all these Army guys at the Quartermaster Corps. You know, they were talking flying saucers to me back then in 1949. That's 2 years after Roswell, maybe 3 years after Roswell. Okay. Now, there's also talk that one of the reasons the CIA was created in 1947 is because of Kenneth Arnold and the flying saucer flap. And I also happen to know from very direct, reliable source that one of the creators of the Central Intelligence Agency was a man named James Jesus Angleton. And Angleton was very, very concerned about the flying saucer issue, took it very seriously. And James Angleton, he collected a huge amount of intelligence on flying saucer events. I know this from a member of the family, okay, a member of the Angleton family. And I know a lot about that. So, but okay, so there we are. But the two problems are related: consciousness, flying saucers, or UAPs. Now okay. Let's go on to the next slide. We come back. You can ask questions about all this later. Let's go to the next slide. There we go. This is important. Now, this is very important. This is a picture, this is a space-time diagram, and what I'm showing are pictures of the local light cones, okay? Now, there's a thing, now the papers, I think I've discovered a serious mistake in almost every warp drive theoretical paper that's been published from Alcubierre onward. Even the guys that they've gotten confused about something. They're claiming, and this is a correspondent, Eric Davis, if you're listening, pay some attention to this. They're claiming there's a problem. They're claiming if you have a warp drive, if it goes superluminal, there's going to be a problem because you can have, they're claiming there's going to be a problem of local event horizons. What's going to happen, I think there's going to be, I forget if it's a black hole horizon in the front of you and a white hole in the rear of you, but in any case, there's going to be horizon problem so that if you're in warp drive and if it's faster than light warp drive, you cannot navigate the ship because you won't be able to see the outside. You won't be able to see the outside because of what's called a horizon problem. And here's an example of a horizon. Look at that dotted orange line. It says apparent horizon for Bob. Okay. This is, see, Bob is the blue light cones. So what happens is, see, the light will never reach Bob. So what's happening from Bob's point of view, if he's trying to look at Alice, at a certain point, Alice is going to disappear from view because no light signals from Alice can ever reach Bob because light signals from Alice, well, or any signal from Alice would have to be outside of Alice's local light cone. And the idea is if you don't have faster light signals, you're gonna, that's called a horizon. But see, internally, there's no problem. Internally, there's no problem for Alice, who's in the ship. She could be going faster than light, and she could see ahead of her. There's no horizon for Alice. The horizon is only for Bob. So people have gotten very confused. What they've done is to confuse what the distant observer is seeing with what the local observer actually sees. So there's no horizon. I claim there's no horizon problem for local observers. There's only what appears to be horizon because they're using the wrong equations. They're using what equations for what Bob sees, who's far away from Alice. And now you could also say, well, what about the problem of colliding with cosmic dust and objects and stuff? That's not going to be a problem either, unless that's not going to be a problem for particles that are surrounding the ship that are also on geodesic motions, because they're also going to be manipulated by the local gravitational field that Alice is controlling within her ship. So I'm saying that the situation for fast and light warp drive, say relative to the Earth, say if we want to get to an exoplanet, fast and light, the situation is not as bad as everybody thinks. Which of course, if I could be wrong, but if what I'm saying is correct, that also means it's a lot easier for hostile aliens, ETs, using warp drive to get to us if they want to like destroy us, military threat. Now, there's one thing that Christopher Mellon, who's Christopher Mellon? He's one of the guys with Louis Elizondo and Hal Puthoff and that clown Tom DeLonge they left. Christopher Mellon, he's a blue blood. Yeah, he's the grandson of Andrew Mellon, who was Secretary of the Treasury and one of the top, most powerful people of his time. Well, not only wealthy, but also politically powerful. And Christopher Mellon, at one point during the Clinton administration, and I think the early part of W's administration, was in the Defense Department, and for some time he was a protege of William Cohen, who was Secretary of Defense, and at one point he was like an assistant Secretary of Defense for intelligence. Even he's not a scientist. He went to Colby College, in history of political science, something. He has like an international finance degree or something from Yale. Of course, they all go to Yale, right? Skull and Bones and all that, and Christopher does say, and I agree with Christopher Mellon on this point, Christopher does say that he thinks these UAPs are a military threat. And Louis Elizondo says that too. Louis Elizondo is kind of he's an army was an Army Ranger or something, Army intelligence, sort of like George Koopman. And Elizondo thinks that, they're a threat too. And of course, we have these, this guy, Frank Milburn, who I know, who I work with. Frank is a retired British Army. I think he was a commando of some kind, red berets or something. And he also writes papers for the Mossad think tank, the Begin Sadat Institute at Bar-Ilan University. He's written two white papers for them, in which my work is mentioned. Louis Elizondo's in it, Chris Mellon, Colonel John Alexander, all this stuff. So I know and of course I know Uri Geller very well. Uri Geller is tied in with Benjamin Netanyahu, and Geller himself was basically a Mossad agent. It's now public knowledge. It's in his books. And of course, we know, the Israelis are pretty smart people, and we know that they're very interested in the military threat posed by what the US Navy is reporting in the Nimitz Institute incidents, and the others. There have been several others now. Is it the Roosevelt and others? There's a whole bunch of stuff. And also I know the Russians, because I've been interviewed by the Russians. Vladimir Putin's agents came and videoed me about a lot of this stuff during the Obama administration. This was years before, I guess around 2014. So I happen to know that the Russian military intelligence, there's Russians in touch with me, that so this is international. They're all interested in it. And apparently also the Russian Navy has had encounters with these low energy warp drive vehicles, the same as the US Navy, and apparently the Chinese may have. So this is happening all over the place. So one thing I want to be very clear about, this is not a theoretical issue I'm talking about. We actually have facts. It's like, okay, when Einstein was testing his general theory of relativity, he predicted the bending of light by the sun, okay? For me, what I'm saying with low power, all these reports by the Navy, now made official by the Pentagon since October 2017, these are like the gravitational bending of light. These are facts. I'm taking these to be facts. I'm explaining these facts. Well, let's put it this way. Maybe it's a big, massive disinformation. In fact, I think it's funny because Chris Mellon's cousin is John Warner IV, who's the son of the late Senator Warner, who was Secretary of the Navy. And they're like third cousins. They even went to summer camp together, and they're on opposite sides of this thing. Okay, I think John seems to think that this whole thing is some kind of cover-up. Maybe John Warner, you can correct me if I misunderstand your position. But in any case, I know you and your cousin, there's a family feud about this issue. So let's put it this way. Suppose this was a massive disinformation thing by the Pentagon and by the global, by the defense, by the military industrial complex. They want to get more money. So suppose they're going to fake an extraterrestrial invasion. Okay, so someone's going to fake it. All right, but even so, my physics still works. Even if this thing is fake, the physics I'm talking about is going to work, and the technology that we're seeing in these observations is explained by what I'm talking about. So whether those Tic Tac, this is from Mike Turbiner, whether those Tic Tac videos are real or faked, I don't care whether they're fake or not, because maybe the joke's on them. Suppose they are fake, Mike, Mr. Turber, who's Air Force intelligence or retired Air Force intelligence. Suppose they're fake. Well, guess what? The joke's going to be on you because we could build these things anyway. But suppose they're real. If they're real, then it's even worse, because then we really have to worry about who's in control of these things, because with these kinds of weapons, these are weapons. They're definitely weapons. With this kind of technology, we don't have a chance. It's like Independence Day. It's like War of the Worlds, unless there's some virus wipes them out. Okay, so I want to summarize here saying that, yeah, this is a military threat, guys. And that's why I'm calling this the second intelligence failure of 2021. Back to 20 years ago, intelligence failure. Clinton could have gotten Osama bin Laden. There was all kinds of screw ups there. The FBI wasn't talking to the CIA. We have similar stupidity happening today. The right people are not talking to me about what this technology really means, what the military threat really means. The Russians take me very seriously. The Russians know what I'm talking about. But the Americans, we have, there's political issues going on here. There's stonewalling. The people in the Pentagon should be talking to me. Randolph Stone, I'm talking to you. You're in the Inspector General's office. You're not doing your job. You should give me a phone call and we should discuss this thing, because it's your job to figure out what's going on. And maybe I misunderstood what your job is. Oh, these guys, apparently the guys who wrote the UAP Pentagon report, a bunch of young guys, young schmucks, they don't know anything. Maybe they're 20 years old, they're young lieutenants or something. They're not physicists, they don't know what's going on. That's why the report was so stupid. It was a nothing burger. All right, okay, all right, enough of that. Let's go on to the next slide. Okay, oh yeah, okay. Now the big thing here is you hear Hal Puthoff, he mentioned he pays lip service to metamaterials, and so does Louis Elizondo. You keep hearing that it's a buzzword. Metamaterials is a buzzword. Do they ever explain how metamaterials fit into the phenomenon? Do they explain why metamaterials? They don't say anything. They just say, oh, metamaterials, we found this debris. We think it's a metamaterial, but it's slag. It's been melted. It's heated. Linda Moulton was somehow somebody gave it to, was it George Knapp or to Linda Moulton Howe? And it's been around for like 20 years. And the one interesting thing that Eric Davis does say somewhere, as I recall, is that the scale of the metamaterials goes down to like an angstrom, 10 to minus 8 centimeters. Lattices with a lattice spacing like 10 to minus 8 centimeters. That's like a tenth of a nanometer. And that's beyond any technology. Now, this was stuff that was found 20, 30 years ago, right? So we didn't have the technology to build that then. So is it extraterrestrial? Well, no, maybe coming from our future. See, it could be time travel. I think it's time travel. I've reasoned, but so the point is that although Tucker Carlson has Nick Pope, who doesn't know anything either. He's a nice guy. He's not a scientist. The Ministry of Defense had him, investigating UFOs, and it's good. It's all good that they did that. But none of them have a clue about how the physics works. And they just say, Louis Elizondo says, the physics is, we don't understand it. Louis Elizondo doesn't understand it. Even Hal Puthoff may not understand it. I tried to explain some of it. I was actually with Hal Puthoff and Kit Green in October, late October, like October 26, 27, 28, in London. And I was with them at this meeting with David Bohm, Centennial. And we were in the hotel room. I remember every calls are coming in from Washington, D.C., from the Pentagon, maybe of Leslie Kean, people like that. And either Kit Green or Hal Puthoff would have to go out of the room and talk, because they didn't want me to hear what was going on. They were setting up the December release from the New York Times. It was pretty funny. I was actually there in the room when all this was going on. So that's a synchronicity. Why did that happen? Well, I can tell you all kinds of weird synchronicities like that, and I can tell you why I think it is happening. But let's go on to the metamaterials. I'm the only guy, me with Keith Wanzer, I'm the only guy who has an explanation based on conventional physics that explains why metamaterials are important for warp drive. And one thing, when I say based on conventional physics, Nick, I'm talking to you. Yeah, of course, I've gone a little bit beyond conventional physics, but only what John Archibald Wheeler calls radical conservative extension of known physics. Very minimal change in what is battle tested, what we know, as opposed to going into like M theory of Ed Witten. It's all mathematics. I don't see any physics there, except maybe they what seems to have some physics is Lenny Suskind's hologram picture is being now applied in condensed matter physics, quantum Hall effect, these edge states, bulk states. That's like the hologram theory of Susskind does seem to have some practical application. It's interesting because he's there with the guy Laughlin, who also did quantized Hall effect. So there is, and graphene, all that kind of stuff. So there is some application of the holograph ideas, but there's a lot of stuff that's going on in string theory that, that's just nonsense. I mean, beautiful mathematics, impressive mathematics. As I say, mathematics, the opiate of the theoretical physicists. Let's go on to the next thing. Next slide, please. Thanks. Okay, so here is more. All right. Well, I'll get back to this. Let me have a little water. The equation, the cosine, Einstein's equation, but has this cosine thing. The cosine comes because the source of the induced gravity warp field is going to be an electromagnetic pump field. Electromagnetic field in dielectrics, and in fact, metamaterial dielectrics. The permittivity, the permeability, the magneto, there's all kinds of stuff in the susceptibility, different kinds of susceptibility when the metamaterial is anisotropic and inhomogeneous and dynamic, what's called space-time metamaterials. You have the constitutive parameters of the metamaterial have imaginary parts. They're complex fields. And they have imaginary parts, and that's because of dissipation. It's heat, like Joule, like the resistance in a LCR circuit. When you actually do the mathematics, it appears like an imaginary part in the basic equations of motion when you do a Fourier transform. In any case, so we have this imaginary part, and that leads to this cosine function. But this is the key. This is beautiful. That nobody's noticed it before. I haven't seen this in any textbook at all. Because you know why? Let me explain something. When you read any book on general relativity, almost, and especially the papers, the theoretical physicists who do general relativity, except for people like Kip Thorne. Kip Thorne's like an engineer, and because Wheeler was an engineer. Except for those guys, they want to be like pure mathematicians. They want to be elegant. So what do? I set capital G equal 1. I set C equal 1. And it's not even there. Goes away. It goes away. I have GAB. It's TAB. So of course they never think of what the hell. They never really think of what's going on inside a material. They don't know solid state physics. I'm not even solid state physics, I must admit. But Keith Wands is a very good solid state physicist. He knows what's going on inside. Okay, but I know it's important to know what's going on inside materials. And then there's this bogus argument. They say, oh, well, it's got to be the speed of light and vacuum in the coupling because that's an invariant. Well, it turns out we can make an invariant for the what under certain specialized conditions becomes like the speed of light inside material. It's invariant. In terms of Einstein's gravity field equations, everything's invariant. Everything is mathematically kosher. Okay? So no, but look, this cosine thing, it's a phase shift. It's a phase shift. What happens is you have, say, electromagnetic fields coming in, and they induce a gravity field, and there's a relative time delay, a phase shift between the input electromagnetic field and the output gravitational field that it's generating. And if that phase shift is right, there's a sign change, and that's anti-gravity. We got anti-gravity, guys. It's there. It's in materials. You don't see it. You don't see it. Normally in most materials, you won't see it because most materials, the dissipation is not that important. And any case, what I'm saying is, prediction now, it's extremely easy to make anti-gravity with hardly any energy at all. You just got to tweak, you just got to tune how much dissipation there is relative to how much non-dissipation is, or in terms of microscopic physics, how much inelastic photon, electron, how much photon scattering off charges, whether negative or positive charge in the material, how much inelastic scattering, which is generating heat, versus elastic forward scattering, which is kind of reactive, which is reversible. If you change that ratio, and if you change enough, the gravity field you induce is going to go from attractive to repulsive. And of course, that's great because that's what you need for warp drive. That's what we see these Tic Tacs actually doing. Now, if you have anti-gravity, you have what's called the blue shift. Because what's happening with anti-gravity, when it actually expands space, it's actually causing it's opposite to what you normally think in terms of motional Doppler effect. So you can have a blue shift. Now let me get back. There's this guy named, you all heard of Bob Bigelow, right? Bob Bigelow and Jacques Vallée and Kit Green and John Alexander and George Knapp, the Las Vegas gang, and they're all tied in with Senator Harry Reid, right? Senator Harry Reid was Speaker of the House at one point. And at one point, Bob Bigelow, who is a Mormon, by the way, no, he's Mormon. That's important because the Mormons are, the Mormon religion is a flying saucer cult, basically, ETs and all that stuff. And and Bigelow was really into flying saucers. And also, he had this thing called the Skinwalker Ranch up in Utah, where all these, if you read, there's a paper, in fact, the High Strangers paper by Jacques Vallée and Eric Davis, they talk about what appears to be a wormhole, a little Stargate, a floating orb wormhole, which a Bigfoot, this sounds pretty crazy, but a Bigfoot gorilla type creature comes out of the damn thing, comes out of I came out of that wormhole right behind me, but this but my cousin Bigfoot, he came out of a real one that was hovering above the Skinwalker Ranch, allegedly. So this story goes back like 20 years or something like that, or 15, 20 years. Okay, so what happens is that Bob Bigelow sells his ranch to another Mormon, another very rich Mormon. Okay, Mormons are rich, they're smart. And there's a guy named Brandon Fugel. And he has, on History Channel now, he has his Skinwalker Ranch series. And they're talking also, they claim 1,000 feet above them, there's this sphere, it looks like there's this thing. They think it's Brandon Fugel has this guy, Travis Taylor, who's kind of right out of Central Casting. He's like a movie star, handsome kind of looks, and he's a astrophysicist. And Travis is his science guy, right? And they claim that, but here's the thing now. They're getting radiation sickness, man. They're claiming that a couple of guys that got sick, they think there's ionizing radiation. Well, what happens is, if you stand beneath a floating flying saucer that's in warp drive, you're going to get sick. You're going to get radiation sickness. Why is that? Because you have the anti-gravity blue shift is ionizing, the molecules and the atoms that are in the air or anything around. It's increasing its energy. It's a blue shift. It means that the energy is increasing. And you're going to get plasma. Yeah, there's just plasma. You're going to see all that stuff that they see. So that the fact that they've been getting sick standing underneath this thing is totally explained as a hovering orb. Okay, by the way, a Tic Tac can be a Stargate too. The two things, it turns out that the wormhole, like traveling through a wormhole, Stargates we get to Mars in a split second by just going through the gate, through the Stargate. That's all. It's the same equation. This equation. It's Einstein's equation with different boundary conditions. Different applications of the same equation. So you can have your Tic Tacs, your flying saucers. They can operate as warp drive vehicles, even going. They can go 100 miles an hour. It doesn't matter how fast they go. They can do everything the Navy reports seeing them do. And then they can also switch into Stargate mode. We can write mathematical solutions. In fact, what's his name? Matt Visser. Matt Visser is a very good relativist. I think he's still in Australia or New Zealand. He's published a bunch of papers on this. On traversable wormhole solutions and how it connects with the warp drive solution. So that's all standard general relativity, and you just have to put the strong coupling that Keith Wanzer and I have used the metamaterial trick to amplify the coupling between the applied stress energy source tensor, electromagnetic field source tensor, and the gravity field it induces. And we understand it. I mean, when I say we understand it conceptually, qualitatively. It's not a mystery. We understand that what basically is going on here. When I say, okay, let me make an analogy with World War II, Manhattan Project. Okay, what happened? 1930s in Germany, Nazi Germany, Jewish woman physicist, Lisa Meitner, I think she was Jewish. She sees nuclear fission, right? in the lab. And I actually spoke with John Wheeler about this. He was telling me about some of this stuff. And John Wheeler was visiting Niels Bohr, in Copenhagen, the Bohr Institute. And and Bohr and Wheeler figured out a very simple kind of model, liquid drop model, I think it was, for how the nuclear fission might work that they're seeing. And so the basic idea, they understood the basic idea of nuclear fission. Right away, everybody saw you could build a bomb, right? That was any physicist, nuclear physicist, Hans Bethe, all these guys, they might say you could build a bomb. That's like what I'm saying. We could build a warp drive. We know the basic equations. There's liquid drop model for nuclear fission, stuff like that. But of course, to actually do it, that's a big deal to actually do it. So although everybody knew, Hitler knew, Heisenberg was, the Nazis knew, and the race was on to actually build the bomb. And it took a Manhattan project. We actually did it with 3 or 4 years, right? That was pretty amazing. A couple of $1 billion. Richard Feynman and these guys, and Bethe, who was my professor at Cornell, and Phil Morrison and Wilson, all these guys under Oppenheimer. And in 3 or 4 years, they actually did they actually built it. And Heisenberg, I don't know, Heisenberg maybe sabotaged, who knows, but the Nazis didn't get it. And they built the bomb. So in the same way now, I'm saying we understand the basic equation, we understand the basic phenomenon in terms of theoretically how it works. But to make a metamaterial that's going to do it, that's a big job. See, that's engineering. It's called engineering physics. The theoretical physics of the phenomenon is very simple in principle. The engineering physics, of course, it's a major job. And now, but again, I want to emphasize the cosine factor. The cosine factor shows us how to switch from attractive gravity to repulsive anti-gravity. And that's the key component for warp drive, for practical warp drive, is what's called dissipative phase modulation, or phase control of the phase between the input electromagnetic field and the output gravitational field. Let's go on to the next slide. Okay, well, that's just that's too. Let's go on to the next one. That's okay, Blake. Before you do it, this just shows anybody who says, any of these assholes, pardon my French, pardon my Brooklyn language, from Brooklyn, Flatbush. Anybody who says that there's an invariance problem with a coupling doesn't know what he's talking about. Just plain incompetent, just stupid, okay? Everything is mathematically kosher. Einstein's field equation is a tensor field equation. The gravity field is a second-rank symmetric tensor on the left-hand side. The right-hand side is a second-rank symmetric stress-energy tensor, and the coupling between the electromagnetic source tensor and the gravity field output tensor, that coupling has to be an invariant. Well, but it doesn't have to be a constant. See, when Einstein got his coupling, how did he do it? He didn't have any fundamental physics there. Einstein did it by what's called the correspondence argument. He forced his theory, his equations, to be consistent with Isaac Newton's earlier gravity field equations, which is called the Poisson equation. And in order to do that, and he needed a speed, and he put in the speed of light in vacuum. Because, and by the way, a lot of the calculations of general relativity are done in vacuum. So actually the coupling may come in at all. There is no coupling. Coupling only comes in when you're inside matter. There are a few, in fact, the what's called the Schwarzschild solution, the Kerr solution, the Rice and Nordstrom solution for gravity fields. The gravity fields in vacuum outside the charge spinning sources. They don't often go into what's happening inside. They don't deal with it. They don't have to deal with it. Okay. So this is uncharted territory. There hasn't been a lot of work. And I was even talking with Keith Wanzer the other day, trying to find literature in stellar structure, neutron star structure, stuff like that. Do they have to use general relativity for the equations of state for what's happening inside the sun or inside, say, neutron stars, are very dense? And apparently, I'm looking through Chandrasekhar, Virginia Trimble, textbooks, all the books, none of them really use general relativity inside materials. Nobody's done it. So it's unknown territory. Now, there's the only person where I could find is hang on, this book. I don't know if you can see it. This is Relativity, Thermodynamics, Cosmology, Richard C. Tolman, Caltech. He was professor of physical chemistry and mathematical physics at California Institute of Technology. This is the Oxford University Press. And when was it? 1934. 1934, guys. And he does have some stuff about what's happening inside. Okay, so if anybody finds, if Art Wagner, you're good at this, try to find some papers, current papers on the equations of state in extreme matter with general relativity corrections. So the point is, all these guys who are like criticizing me without knowing what the hell they're talking about, they don't even know the literature. They don't know there's no evidence that has to be the speed of light inside. There's no evidence that if you're talking about what's happening in the physics of matter inside materials, especially these metamaterials, which have these extraordinary electromagnetic resonance properties, that there's no evidence in any experiment that the coupling inside the material is the speed of light in vacuum. There's no evidence for that. No empirical. There's no reason for it. But they quote it like verse. It's like a biblical scholar saying, you know, that God created the earth in 7 days. And it's like that literal. You can't. And if you question it, you're a heretic. Burn them at the stake. I mean, it's that kind of bullshit from these guys. What's wrong with these assholes, Mr. Knuth and all you guys? All right. You're being stupid. So pardon me, but that's my honest opinion. All right. So there's this stuff. We'll get back to this. Let's go on to the next slide. Okay. Well, that's okay. Again, this is just the gravity redshift. This is the looking at this. This is the ship is moving to your right on your screen. It's moving to the right. The gravity redshift is at the nose, and the gravity blue shift is at the tail. Let's go on to the next one. Okay, just driving the point home once more that when you have positive curves of space contraction, time expansion, gravitational redshift, anti-gravity negative curvature, space expansion, time contraction, gravity blue shift. Let's go on to the next one. Okay, just repeats. All right, you know what now? I think I've been talking long enough. I don't know, is anybody still there? Am I talking to myself? Is anybody out there? At this point, Tim, let's switch. Let me get to my iPad. Let's see if we can do that. And let's start taking some questions. We could always go back to the slides if we have to. Let's start taking some. Now, let me see. Okay, are you there, Tim? What's happened? Wait, I'm mute. I can't hear you. Can you hear me? Wait a minute. I can't hear you. You're recording. I don't want to mute. Tim, if you're talking.
Oh, sorry. Can you hear me now? Okay,
Okay.
I'm sorry. That's my fault. Yes. Thank you, Remy. I was on mute. What I want to do is have this on. Everybody, we've got it on gallery view. Everyone, please give Jack an enormous hand for the beginning part of that presentation.
All right, that's all right. I don't need a hand, but I am going to need my iPad.
Well, we have to clap, and that was you drilled through a ton of material as well. So
and I didn't only touch the surface. I mean, there are several things here. There is the politics. There is the intelligence stuff, you know, CIA type stuff, you know, the black ops stuff, and the physics. There's the physics, and you know, I have things to say on all that, because I'm a firsthand, you know, I'm right in the thick of it, so to speak, and have been for 70 years. That's what I want to point out. This didn't start. This started when I was a kid, man. And in fact, I can even go back to when I was 4 or 5 years old. Really weird shit. Okay, So I've been involved with this my entire life. All right, and there's a paranormal component. This is what Jacques Vallée calls high strangeness. That's very much a part of what's going on, and it's very much a part of what's happening right now with all this Pentagon stuff and the Russians. Don't forget the Russians and the Israelis, and the all the intelligence features. But let's see if I can get my. I want to see now. How did we get back to the? I want to get my iPad so I could draw. Do you remember how we did that? Jim?
Yeah, yes. So you went onto you were on your Mac and you shared screen on your Mac.
Oh, yeah. Let's see. Oh, share screen. There we go.
Yeah, and I think you're still connected to your iPad. I'm not sure when to sleep.
Okay. So AirPlay, is it this one? Share. Let's see.
Okay, so now it's in screen sharing.
Okay, can you see? Let's see what's happening. Tap screen mirroring. Where's screen mirroring? Tap screen mirroring. You're screen sharing. Oh, I have to go screen mirroring here?
Yeah.
Come on. Okay, screen mirroring. No. Damn it. No, I didn't do that. Screen. No. That's not what I want to do. If anybody has questions, they can let other people talk while I'm doing this.
Okay. Jeremy Reese actually had a question. Let me go to Jeremy then.
Okay, wait just a minute. Tell me if you're seeing it. It's spinning. It's spinning. It's like it's trying to do it.
There we go.
There we go. Isn't that fabulous? Okay, now, but how do I get my? All right, there we go. And I'm gonna go here. And I'm going to do this. Now I am ready for anything. So Nick, if you want to duel, we can duel.
And
I got my trusty. The Apple Pencil is mightier than the sword.
I'm not sure if Nick is still on.
I see him.
Oh, okay.
Exactly. Okay, Nick, I'm going to duel. We're going to duel with the get your Apple Pencil, Nick. The Apple Pencil's mightier than the sword. Okay, go ahead. I'll stop fooling around. All right, go ahead. What's happening?
Oh no, it's up to you, sir. So yeah, you mentioned you wanting to draw on the screen to equations and stuff like that. So we have you spotlighted. You're on the kind of the right hand corner, and then it's actually showing your iPad screen. So
yeah, right. Well, I'm waiting now for questions.
Oh, okay. Well, yeah, absolutely. So let me start with Jeremy Reese. Jeremy?
I don't see him.
I'm here now. I just had to unmute. Jack, I had a question. You mentioned John Archibald Wheeler's involvement with a lot of the theoretical research into some of the stuff back in the 50s and stuff.
Yeah.
And also Froelich going back to the 30s even and stuff. Do you think it's possible that any kind of faction of the scientific community figured some of this stuff out before?
No, it's not. It's not possible. Well, let me first say something about Wheeler. Okay, I think Wheeler's cousin was General Earl Wheeler, if I'm not mistaken, who was at the time the head of the Air Force. Okay. And I also know that was it Kurt LeMay? We have from when we were at when Joe Firmage in 1999 set up this ISSO. There was a guy, one of our scientists, and you could his father was a friend of Kurt LeMay. This is the story we got, okay? And so he's a little kid, and Kurt LeMay would come over to his father. His father was an Air Force guy, a Strategic Air Command guy. And Kurt LeMay would come over with these videos, with these film strips. They would go down the basement and play, and they were UFO encounter films. Are you there? Can you hear me? Is everybody hearing what I'm saying?
Yeah, I can hear you. I think Jeremy muted himself back out so he wouldn't disrupt.
Okay. All right. So, any case, so Curtis LeMay was showing these flying saucer films to a group of officers, including this guy's father, in our friend's house, and he would watch these films. He's a little kid, they don't watch. Okay, that's how he got interested in UFOs. What happened here? Oh, I see what happened. Okay, nothing happened. All right. So now, but the point I wanted to make, though, was that up until 1952 or so, Wheeler's main work at Princeton was nuclear physics. Okay. And what I think happened, I know, this is now I'm guessing, educated guessing. What I think happened was that Earl Wheeler read John Wheeler in on all this stuff that was going on. And that's why John Wheeler shifted rather abruptly and dramatically from his work in nuclear physics to general relativity. And that created the whole revolution in general relativity, which was really created by Wheeler and his students, in particular Kip Thorne. Okay. Didn't
Wheeler also get into metallurgy really heavily? He was like
Wheeler originally was a chemical engineer. He was a metal. He started school. He started out as a chemical engineer.
Yeah.
That's why Wheeler in the Manhattan Project, he was in charge of Oak Ridge, all that chemistry.
Yeah.
All the radiant chemistry. Because that was his original background.
And also, what about Mills Purcell? So his theories started like the whole revolution in nuclear magnetic resonance, which led to the development of metamaterials.
I don't see. You may know something I don't know. I don't know that Purcell at Harvard, right? He was at Harvard, right?
I believe,
Purcell's
yeah.
Harvard. That led to metamaterials? Maybe. I don't know.
He headed the CIA's Project Rainbow, which was all the invisibility stuff back in the.
Yeah. Okay. Yes. I see what you're getting to. Right. I'll do this again.
Yeah, so I didn't know. Like his research seemed interesting and stuff. I just didn't know.
Okay.
And what about as far as metamaterials? Do you know of any companies that are producing these or anything like that nowadays that are trying to do these?
I don't know. I don't. I'm saying, remember there's been COVID, so we've been virtual quarantine. I only see what I see on the internet. What guys like Art Wagner, who goes through the literature, send to me. And remember, I'm not a metamaterial physicist. I'm not a solid state physicist. But Keith Wanzer is more along those lines. He's a real expert. He does experimental and theoretical physics in that area. So he's the guy. I want to try to get this again. So what happened?
I know there's a company in Dartmouth, Nova Scotia called Metamaterials Incorporated, and they have a lot of optics and solid state guys who work on developing metamaterials. I don't know. They don't reveal much about any products or any kind of things that they're developing, though.
Okay.
Yeah, and it looks like it's, there we go. Yeah, it looks like it's woken back up for you, Jack.
Yeah, it happens every now and then because the thing goes, the power's down. All right, so, so Jeremy, any more questions about that?
Yeah, I was just trying to think of, if there's any way that someone could have produced some kind of material before that it just doesn't seem.
See, here's the thing. See, these guys piss me off. Hal Puthoff, who is a good guy, especially Eric Davis, they piss me off because they throw up all this national security. It's classified. They're keeping everything secret because they're hiding their own ignorance. The only important thing that Eric Davis has said, he said that the alleged retrieved material, right, has metamaterial lattices down to an angstrom. That's like the size of a hydrogen atom, right?
Yeah.
So there's no way, none of the metamaterial guys are working, they're doing like inches, they're doing acoustic inches, maybe microns, and maybe nano. I don't know if they're down to nanometers yet, maybe. But that's what the new Manhattan project that I'm calling for would be.
I had heard that they were doing high temperature, high pressure hydrogen crystals is what they were using.
But that's clearly, that's well, so what? I mean, the Tic Tac, the flying saucers, they're not using high pressure materials. I mean, right? They're using something that's operating under regular pressure,
right,
in the atmosphere. So
yeah, you wouldn't be able to contain the pressure on that if it's a surface material.
No, what they do with that? That's barking up the wrong tree altogether. Okay, there's something What we need is, we need these dozens, maybe hundreds of solid state guys, nanotechnologist guys, computer simulation guys. We need the kind of computer facilities that Kip Thorne used when he did the black hole collisions, gravity waves coming from black hole collisions and neutron stars and the Interstellar movie. You need that kind of computing power to simulate, And then now I do know this, that there are now artificial intelligence programs that are actually designing metamaterials, but probably probably not down at the angstrom level, micron and stuff like that. So artificial intelligence is going to play a role. And when I say artificial intelligence, I mean just ordinary artificial intelligence. I'm not talking about the conscious artificial intelligence that I'm also working on. It's a separate thing. All right. So does anybody else?
Oh yeah, actually, Jack. So the next one that we had. Well, Jeremy, let me come back to you in a bit.
Oh, saya suara mau jam.
I'm sorry about that. That was
Okay.
Thank you, Jeremy. So let me go next to. Let me see. Let me go next to Christopher Plain. Okay. Sorry about that. I'm gonna have to change that a little bit there. Okay. So Christopher, he was asking about. Let me see. And I just muted out that individual. I'm not sure who that was. Christopher, let me unmute you. He was asking about how far in the future Jack thinks Tic Tac pilots are from.
Well, I don't know. That's a good question. I can tell. All I have is hearsay. I could just now we're getting into the eye strangeness. Okay, this is pure. Okay, let me. What is Wheeler talks about? There are a few iron posts of observation in the paper mache of theoretical speculation. Okay, all I know is this: when I was a kid, when I was 13 or so, I had a contact with a Tic Tac. I didn't call it a Tic Tac then. Now in hindsight, I know it was a Tic Tac. And I'm not going to spend too much time on the story. But all they said they were from the future. They told me they were from the future.
Telepathically?
What? No.
Using a voice or telepathically?
Not telepathically. Not telepath. No, this was on a phone call. This is a whole story. This has been written about many places. This was a series of phone calls I got on the telephone with a cold metallic voice that sounded exactly like Stephen Hawking's voice later on. Okay. This is called, and this is a voice also that my mother finally grabbed the phone and she heard, she talked to it too. Okay. So I wasn't imagining it. And they said it was a conscious computer on board a spacecraft from the future. This was 1953. And they said I would begin to meet the others they had selected in 20 years. 20 years goes by. It's 1973. And I'm suddenly, by a very set of strange circumstances, I wind up at Stanford Research Institute with Hal Puthoff, Russell Togg, Brendan O'Regan, Edgar Mitchell, Dean Brown, a whole bunch of people, other people I can't remember who they were. And some of that, it's a CIA thing. And some of that CIA recording is actually on the internet. You can hear it. You can hear us talking about UFOs in the future in 1973. I talk about my phone call back in 1953. 20 years, on cue.
Wow.
Okay, that's important. See, people are so stupid. I mean, what you need is to be like, I'm like a cop. I'm doing forensic now. I'm not only doing physics here. I'm like a homicide. I'm like, Inspector Clouseau. Right? I'm almost like, hey, we got there's a crime going on here. We got these clues. Okay. Also, and let me say this: there's this guy Paul Hill. Back in the 50s, he wrote a book called Unidentified Flying Objects, and when he did a forensic, he took information that he had. He was part of what was the pre-NASA, I forget what they called it, and he tried to figure out how to explain the observations they had there. And to his credit, he kind of figured out it had to be like a warp drive. But this is 1953. He didn't know any general relativity. He was an engineer. He was a good aeronautical engineer. He only knew about motion, things moving through space. He didn't know about warping space. But he came up with a concept called acceleration fields, which is basically warp drive. And he did that by pure empirical inference, like Faraday, like Faraday doing lines of force, things like that. Humphrey Davy, empirical stuff. But I'm sort of doing that here too, except I know some general relativity. I'm taking the information, the clues, and that includes my high strangest contact through the telephone, which apparently happened over 3 or 4 weeks, though I only remember the first phone call. There's a missing time. It's classic UFO abduction stuff, okay? Missing time, all that stuff. That John Mack was investigating, and people like that. We have to.
And you were going to tie this back to a time you thought the potential time in the future where these
Okay.
Yeah, and actually, let me, Christopher, if it's okay, let me ask you to turn your camera on, sir.
I'm at the wrong computer right now, Tim.
Oh, okay.
Yeah,
no worries.
Right.
When I screaming with you guys, I usually don't have my camera on. I'm sorry.
Let me give you a number. I'm going to give you a number 100 years.
Okay.
Let me tell you why. I'm going to tell you why where that number comes from. I'm not making it up. This would have been, so how many years ago is this now? This would have been, let's see, in the 1970s, was it? Yeah, like 1973, 74. So that's about 50 years ago. What happened was at SRI, they were doing experiments with not Pat Price, Ingo Swann, okay, the psychic Ingo Swann.
Mm-hmm.
This is a story that Saul Paul Sirag told me through his girlfriend at the time, Barbara Honegger. And this was at the Henry Dakin, now dead. This was at Henry Dakin's Paranormal Laboratory on Washington Street, where Saul Paul Sirag was actually living there with Barbara up in Presidio Heights. And Brendan O'Regan came over, and Brendan O'Regan, he was the liaison between Stanford Research Institute, the CIA, and Edgar Mitchell. He was kind of Edgar Mitchell's Man Friday. And well, the story goes that they were doing remote viewing experiments on Ingo Swann. Get this now, okay? Ingo Swann goes into a trance. He's a trance medium type guy. He starts speaking in a cold, metallic computer voice.
And this is 20 years after your phone call.
Yeah, 20 years
Series
after
of
my phone
phone
call. Yeah, 20 years after my phone call. The same kind of metallic voice that I heard, okay, as 20 years before. This was maybe in 1974. So you have to talk to Saul Paul Sirag and Barbara Honegger if she's still alive. If Saul Paul, I don't know if Saul, he's not senile, but and it said it was 100 years from the future back then. So it would be 50 years from, roughly 50 years from us.
Interesting. Thank you. I had put one other question in the chat, Tim. It was about the connection between consciousness and UAP.
Yeah.
And is that just a more or less like a Hal put off Jacques Vallée sort of theory, or do you have your own?
No, not my own theory. No. We all agree about this roughly. No. It turns out the physics of UFO propulsion and the physics of consciousness generation are two sides of the same coin. They're closely connected, mathematically speaking.
Okay.
It has to do with Froelich. It has to do with the Froelich condensate effect. Okay, you have to go to Hameroff. Stuart Hameroff says that the microtubules are where consciousness is generated.
Sure, that's
right?
pretty recent, but yes.
Yeah. Okay. Now there's this other thing whether he's working with Roger Penrose with gravity collapse. I'm not going to talk gravity collapse right now. That's a whole other issue. The exact mechanism how that happens, but the idea that consciousness is generated in the microtubules is like an empirical thing that caused Hameroff to think of it. And I think that was a valid insight. I agree, I agree with Hameroff on the empirics, that I think it's most likely that that's where our consciousness is generated. And guess what? Microtubules are metamaterials. They're natural metamaterials. They're tubular metamaterials. Electric dipoles. Okay, so the metamaterial, and they're pumped. They're pumped, and there's a lot of controversy whether they're a Froelich condensate. I mean, basically, the picture is this: what a Froelich condensate is in a pump system, it's sort of like a laser. A laser, it's an unequal. See, here's the thing: what they are, they're room temperature superconductors and superfluids, but they're non-equilibrium. They only exist. They're emergent only when the energy flow input is above a certain critical threshold. It's like the critical threshold for lasing. It's very analogous to a laser. Laser is a non-equilibrium open pump system, as opposed to the superconductors in the Josephson effect, which are thermodynamic equilibrium, the Cooper pairs and all that stuff. That's an equilibrium. But what I'm claiming, there are a lot of claims here. There's a lot of technology here. I'm claiming that everybody's been very stupid for the last 70 years. They've been trying to get high temperature superconductors, but the schmucks, what they're doing, they're keeping everything in thermodynamic equilibrium, lowering the temperature with cryogenics. I'm claiming you get superconductors at room temperature, even higher temperature, by pumping the systems resonantly into these Froelich coherent states. And like in the metamaterials, in any material solid state system, you have what are called quasi-particles. And there are all kinds of quasi-particles. Some of the quasi-particles that are induced have charges like Cooper pairs. They have polar octanes, all kinds of stuff. So what I'm claiming is that if you pump the stuff, you get into this coherent state, and that amplifies the coupling between electromagnetism and gravity, and at the same time generates consciousness. So it's a conscious computer. The conscious computer is built into the metamaterial fuselage. It's both. It's a conscious. It's like a living entity kind of, but it's on It's a solid state. It's a solid state. Like John Lilly used to talk about these solid state, and it's a solid state entity like John Lilly. It's conscious, but it also it propels it. It goes. It warps space time. It controls space time, and it's conscious. So it's the command, control, communication, navigation system of the device. Now there may be living creatures inside, but you don't need them. They're kind of redundant. Maybe the grays, little grays.
Yeah, but you're saying the material is inherently conscious due to this method.
Yeah, but it has to be, because that's the only way. You see, it requires a quantum hyper. Okay, no, wait, computers. Let's say a few words about computers. You got classical computers, right? The computers, these are classical computers, right? And they're described by Turing machines. Turing machine, you read Roger Penrose, Shadows of the Mind, The Emperors of the Mind. So what is a Turing machine? Turing machine is basically, it's a tape, it's like a tape head. And then, it's the squares. The tape moves one cell at a time, but only moves forward in time, right? Any algorithm is a set of rules that moves one way forward in time. Okay, okay. Quantum computers are different though. Quantum computers, because of entanglement, and now like Nick Herbert likes to talk about entanglement, but Nick and all these guys, as far as I can tell, Nick only knows really about orthodox quantum theory, the von Neumann projection operator, what are called strong measurements. I'm not sure Nick can correct me if I'm wrong, but I'm not sure if Nick ever really read carefully Yakir Aharonov's idea of weak measurements. And the weak measurements is a finer, it's a more subtle kind of measurement. And it's like the strong measurements of von Neumann are like a zip file of the weak measurements. And in the weak measurements, if you read Yakir Aharonov's papers, the weak measurements, it involves entanglement is explained as back from the future influences. In other words, the final measurements actually act back on the creation of the event. So these time loops, that's this whole kind of thing that I'm talking about in general terms. What do you call it? The Yakir Aharonov, actually back in 1964, he first did the papers, Aharonov, who was a student of David Bohm's, by the way.
proposing that backwards effect in time.
Yeah, and now this whole idea of Aharonov has been resurrected and sort of done in a more popular way by a guy named Huey Price. Huey Price is the Bertrand Russell professor of philosophy and physics at Trinity College, Cambridge. And yeah, he has written in the last few years, explaining how entanglement, how non-local entanglement is really locally retrocausal and it's consistent with relativity. And by the way, the first guy who saw, actually, it was really what this is. It all goes back to the Wheel of Feynman classical electrodynamics in 1940, and it goes back even before that. A guy named Stuckelberg had it. So it's been floating in the air from the very beginning of 20th century physics, various versions of it. And actually, Fred Hoyle was also into it. Fred Hoyle in 1983 or so wrote a book called The Intelligent Universe, where he has that information's going back from the future. And it's also involved in the Feynman path integral, because, okay, whenever you have a Lagrangian interpretation, Lagrangians are global, and really the Lagrangian involves influences from the future and the past. In fact, if you look at Feynman's original paper on in 1947 in Reviews of Modern Physics on, I think it was non-relativistic quantum mechanics from his point of view, he has two different wave functions. He has a wave function coming back from the future, and he has a separate wave function coming from the past. So you have the present, you have a wave function coming back from the future to the present, and he has a separate independent wave function coming from the past to the present. The two of them, they meet at the middle. They meet at the present. They're two separate wave functions. They each have their own complex conjugates. Okay, and that's what. So that's what must have motivated Aharonov. Obviously read Feynman, and he built up a whole thing with weak measurements. See, Feynman didn't go into weak measurements, so there's a whole bunch of stuff. And the weak measurements are actually of practical laboratory importance, because there's this guy Ephraim Steinberg, who was doing all kinds of like practical, optical. They're measuring stuff that you can't measure normally. So weak measurements, it's a practical engineering. It's not just theoretical. It has practical implications. And Huey Price from Cambridge in the last 5 years or so has shown how to understand entanglement in terms of these what are called coast. Oh yeah, there's Costa de Beauregard. Okay, this is interesting too. Costa de Beauregard is a French physicist connected with the Institut Henri Poincaré, with Vigier and de Broglie. These are all like students of de Broglie. Broglie, okay? And Costa de Beauregard, he was also involved in all this paranormal stuff. In fact, I'm pretty sure Costa de Beauregard visited Put-Off Target at SRI around the same time I was there. In any case, I forget how I met Costa de Beauregard, but I spent a couple of days with Costa de Beauregard when I was there with Fred Allen Wolf in '66 at the Institut Henri Poincaré. And it was like Parsifal, because I was so stupid, because I was like Nick, I was dumb like Nick, because I was into all the Wheeler and the collapse, and Niels Bohr and Heisenberg, potentia into actua, and Costa de Beauregard, he was trying to explain all this stuff to me, like a dumb idiot I was back then. I sort of didn't get it. It was there in my subconscious. I sort of, part of me got it, But I was exposed to these ideas back then and kind of slipped by me. I'm too stupid to get. So Costa Beauregard knew what he was talking about. He was right. And now, okay, but let me bring you up to date. So there's all this stuff going on already back, the beginning of quantum theory. Yaka Aharonov calls this, he says he has two wave functions. The destiny wave function, which is back from the future, destiny and history. And the two things meet together, it's a weak measurement, okay? And now if you throw away all the information from the future, you get the ordinary strong measurement, you get what Nick Herbert likes to talk about, and what, that's the von Neumann theory. So you get back to von Neumann theory is a limiting case of the weak coupling. The weak measurement theory is a more general quantum mechanics. It's a finer structure to the quantum theory. It's consistent with with the orthodox theory. And if you throw away information from the weak measurements, you'll get the strong measure. You'll get exactly what Henry Stapp doesn't do weak measurement. He does everything he does in his theory of consciousness. It's all strong measurements. Stanley Klein, all these guys, they don't know about Harada. Okay, but now what's even more important? In 2015, there's this guy, Roderick Sutherland. Okay. Sutherland, he was a physics professor in Sydney. And fortunately, he made a lot of money on the stock market. So he became independently wealthy about 20 years ago. And he just maintained his his status, he took an early retirement as like an emeritus professor at the University of Sydney. And he's able to do whatever he wants to do, to follow his, and of course he's into Bohm. So what Sutherland has done is a whole series of papers. Roderick Sutherland on the archive, you get his papers; they're very good. And he took Bohm's 1952 pilot wave theory, okay,
Yep,
variables, which had a problem because it needs configuration space for entanglement. It gets very complicated, and it's inherently non-relativistic. And he showed, so what Sutherland did is he synthesized Yaki Aharonov's weak measurement theory, which is fully relativistic. Weak measurements, fully relative. It's a Lagrangian thing, fully relativistic. It's manifestly covariant, no problems with relativity, even with entanglement. And he showed how to couple it into Bohm's picture. Okay, so it's the Bohm, and it's this ontological picture, realistic picture. That there really are particles moving in continuous classical trajectories, the Bohm quantum potential, but everything is now relativistic because everything is done in terms of weak measurements, basically, okay? But he also includes action-reaction. What does that mean? See, the terms action-reaction in Copenhagen interpretation doesn't mean anything, because people like Nick, who's a Copenhagenist, basically, they say, and who's this guy? He died. There was some famous Israeli guy, good physicist. I forget his name at the moment. He said the wave function is the complete description of quantum reality. The wave function, complete description of quantum reality. So as soon as you do that, you throw the baby out with the bathwater. There's no part. There's no classical, and then you have what's called a reality problem. There's a problem. There's a problem. Classical. How does the classical limit emerge? Decoherence, all this bullshit, all this stuff you see. They threw half the problem out. And so the point is this: what David Bohm and Hiley, if you read David Bohm's later works, and if you read some Basil Hiley stuff, orthodox quantum mechanics, in which you have what's called no signaling, right? You cannot use entanglement as a direct superluminal or back, even retrocausal command control communication system, because what happens is you have to have, in order to, suppose you want to encode a message on entanglement, in the entangled wave function. You can do that, you can encode the message. But in order to decode it, you have to have a classical key. In fact, this is the whole idea of quantum cryptography, is based on this notion. And that's what you read David Kaiser's book, he describes this whole thing, okay? And Nick Urban actually has a good way of describing. He says, you cannot, I think Nick says you cannot locally decode the entanglement signaling. You need this classical key, okay?
Yep.
Now, get this now. What Bohm showed is that the reason for the no cloning theorem, the reason that you cannot use, the reason that's the quantum noise is uncontrollably random and locally cancels out any information at one end of the system without information in the classical signal coming from the other end of the system. The reason for that is that in quantum mechanics, the wave function in the Bohm picture, let's say, the wave function, what we call the Bohm quantum potential, it's a physically real field that changes the classical motion of the particle, okay? So what happens is the quantum field, the quantum information field, the Bohm potential, the Q field, okay? It's a physical field. it changes the classical motion of the particle. So the quantum wave function acts on the particle, but there's no direct reaction of the particle back on the wave function. And if you assume that, then you get the no-singly theorems. That's conventional quantum mechanics.
Yep.
What does that sound like? That's exactly the situation in classical relativity. Because in classical relativity, what happened in 1905 in special relativity, from the modern point of view, is that space-time acts on matter, but there's no direct reaction of matter back on space-time in special relativity theory. That is, there's no gravity. And what does that mean? What does it mean for space-time? Now I'm going to get back to geodesics. What does it mean for space-time to act on matter? It means that if you have a neutral test particle in flat space-time, out in the sticks away from all masses, it means that the time-like geodesic, the natural motion of a neutral test particle will be in a Euclidean straight line at constant velocity relative to anybody else. Okay, that's what that means. It means no gravity. So, but what Einstein, it took Einstein 10 years of struggle, 1905, 1915 or so. He had he had to learn tensor calculus. Right? He had this Marcel Grossman, his friend who was a mathematician, show him how to do tensor calculus, and he struggled. He was fighting David Hilbert, who was a good mathematician, got there a little bit before him. He was struggling to get these tensor equations, okay? But the key thing, there were two physical ideas in general relativity. One is the equivalence principle, which we'll have to get into, the equivalence principle. What that means, it actually has, it's pretty complicated what it really means. It has several levels of meaning. We have to get into that because it's relevant to the warp drive issue. But there's also the idea that space-time was, okay, in special relativity, the space-time is infinitely stiff. You can't bend it at all. Because especially it's as if the speed of light is infinite. Okay, in a way. You can't bend it at all. It requires infinite energy to bend it. Okay, so Einstein finally realized that with the stress energy tensor, you can bend space-time. But even the way general relativity is today, it's not as stiff, it's not infinitely stiff, but it's still pretty damn stiff. It's so stiff that you can't do anything fun. You can't have fun with it. You can't be like Q in Star Trek, except now we can. That's what the flying saucers are. See, the flying saucers are low power warp drive technology with being controlled and computed by the conscious AI. Okay, now I have to get back. I stopped explaining something. There is what's called, now we're talking about this classical computers. Turing machines that the tape moves only one way in time, forward in time. Then you have kind of like quantum computers, and in the weak measurement sense, there's some backward in time influence in the quantum, using entanglement as a resource. That's a backward in time, and you could sort of do things with quantum computers that you cannot do with classical computers, and our whole quantum cryptography technology is based on that. I call that the Maginot line. That's the new Maginot line. They think it can't be hacked. It can be hacked. It can. It's not as secure as they think it is.
Yeah, just like the original.
Wait, because let me tell you why. Because
We're dealing with natural particles.
no, forget that. I'll tell you why. The reason is because there's something called hypercomputation. Well, I call it post-quantum computation. There's classical physics, there's quantum physics, and now there's quantum physics. In the same way, there is non-relativistic mechanics, there's special relativistic mechanics, and there's general relativistic mechanics. And the transition from special relativistic mechanics to general relativistic mechanics is the same conceptually as the transition from quantum mechanics to post-quantum mechanics. It's the restoration of this generalized action-reaction principle. It goes two ways. So now what? There's a guy named Seth Lloyd, and there's a couple of guys. It's not just Seth. Actually, it was David Deutsch. I think David Deutsch. Yeah, David Deutsch had this too, but they had like different versions. They said, suppose there's time travel. Suppose you're able to go back, the loops in time. Closed causal, in general relativity, you have what are called these closed time-like loops. We can literally send particles back in time. Okay. without violating anything, without violating general relativity. Locally, special relativity is obeyed. This is kosher. This is and what they're able to show is that if you have a computer, a quantum computer, that also has like a little wormhole in it, has some kind of a time machine in it, that's called hypercomputation. Okay. And what I'm saying is there's a connection. The action and reaction in the quantum theory corresponds to closed time-like loops in general relativity, and you have this hyper computation capability. You can do all kinds of stuff you can't even do with quantum computers. In particular, you can hack the regular quantum cryptography. You can hack that. These are papers by Sutherland. He shows all this stuff. Okay, shows what you can do if you can actually send particles back through a traversable wormhole. Back in time, you can do all kinds of new amazing things. And I also claim that's what you need for consciousness. In fact, in our consciousness, we're effectively doing that. Because what he shows is that, see, with action and, gets into this. You heard of Lenny Susskind, ER equals EPR. There's a kind of duality that that EPR entanglement connects with Einstein-Rosen wormholes. This has to do with holography, the whole holography idea. Now, if you go back to my book, my comic book with Fred Wolf and Bob Tobin, this crazy comic that we wrote Star Wars with the Cafe. We stupid stuff in that book too. But in that book, I have in the original, the edition, there's a whole story there having to do with Ira Einhorn. Well, in any case, there's a whole other side story there. But in that book, I have ER equals EPR, 1974, 1975, before Lenny Susskind even heard of it. And Lenny and I used to work together a little bit at Cornell in 1963, which is another synchronicity. Everything's connected. A lot of Jungian synchronicity. I had ER equal EPR, but I had it as traversable wormholes in which signals can get through, creating consciousness. I had all that back in 1975. And where did I get it from? I don't know where. I got it because the Tic Tac, because they're talking to me from the future. They're telling me these ideas are being implanted in my soul, they're coming out. I had all that.
Great. Hey, Dr. Jack, thank you for bringing that full circle for me back to the consciousness and the UAP. That is the only question I have left. Tim, I'm going to hand it back to you here.
Okay, well, and thank you so much, Christopher. Okay, so let me mute him out. Okay, and then actually, let me go to Remy. Remy had asked about, Remy, if you're there, let me ask you to unmute. Remy had asked about the fourth order Riemann-like tensor. And Jack, that would give the opportunity to do the scribble on the iPad screen.
Okay, let me get back. Okay, I have to now get it again. I lost it. No. Ah, there we go. Screen mirroring. Yeah. Okay.
Hi, Jack. Good
Okay,
presentation.
now, hang on. Let me just get it. Okay, Mac. Wait, no, okay, so now do I have it? Let's see. Okay, yeah, you see, good. Oh, that's my hey, let me see what happened to do that. Oh, there we go. Yeah, look at that.
Oh, it looks like screen sharing might have gone off on it.
Yeah, no.
There we go. Okay.
No, that is that. Now I want to get my. There we go. Okay,
there we go.
Now, all right, now there's papers. Is Matt Visser? Wait, let me. Matt Visser.
Yeah, he's well known. Yeah.
Visser, and there are two guys, Medina. You just go Medina, Stephanie.
Okay.
This is all archived, ARXIV. Okay, just look at them. Okay, and now let me go. All right. There's okay. I'm gonna use Matt Visser's notation. Calls it Z A B C D. This is a fourth rank susceptibility tensor for all matter, all electromagnetic susceptibility. tensor. And for example, this is fourth way, and this is for the EM, electromagnetic response of any material, in principle, any material to an input electromagnetic field, okay?
Related to the Riemann tensor at all? Is it?
No,
related-
it's not the Riemann tensor.
Oh, thank God. Okay.
Now, you don't know what the hell you're talking about, Remy. Just shut up, okay? Shut up, you stupid. The Riemann, not the Riemann. No, it's not the Riemann tensor. You see,
Okay.
the fourth rank tensor doesn't mean Riemann tensor. This is a classical electromagnetic theory. Nothing to do with general relativity yet. Okay?
Of course, that
In
one.
particular, Z0, I think I0J. Okay, A, B, C, D, those go 0, 1, 2, 3, 4. The I and J just one a space-like, In
Yeah.
other words, you have like these are space-like, time. You have here. This is called this is called what do they call that vector? The time-like vector, and there's a shift vector, and J. This is the ADM formalism.
Yeah.
Okay, this is epsilon ij permittivity.
Okay.
Okay, then there's stuff with the there's the space-like stuff. It's the permeability. There's all kinds of other stuff. You get all kinds of stuff in anisotropic materials. You can have you apply an electromagnetic field here. You get a magnetic field there. Or there's all this complicated stuff. But every possible physical effect, electromagnetic response effect to an external EM field in any material can be described by this tensor. Okay. And by the way, this tensor is a pure number. It's a complex field. This is a Z A B C D. It's complex. I can't draw. Complex tensor field.
Yeah.
So it's Z A B C D. It's like in polar, I'll use polar rather than B, C, D, E to the I, hard, Z, A, B, C, D. It's a complex field, okay? It's space and time, right? X means space-time. All right, now, what Keith Wands and I have done, okay, so let me tell you how this first happened. The history of this. 2011, General Pete Warden, USAF Space Command, takes over. He retires from the Air Force, takes over NASA Ames. NASA Ames. Okay. NASA Ames. NASA Ames. Okay. And one of my former, a guy, he was kind of an informal student of mine, younger man named Creon Levitt.
Mhm.
Is kind of Pete Warden's right-hand man, his assistant helping to run NASA Ames, okay? This is like, when is this? I guess, around 2010. It's around 2010. 2010. Okay, so, and then there's this guy, Doug Trumbull. Let's make this an interesting. Doug Trumbull. Does anybody know who Doug Trumbull is?
Sounds like the guy from 2001. Is that the special effects guy?
That's right, that's special effects.
All right.
2001. Doug Trumbull, guess what? Doug's very into UFOs. He's a UFO nut. Doug Trumbull, who I know through Marshall Navy. Who is Marshall Navy? Marshall Navy, there's a whole, I could go on through. Okay. Marshall Navy was a billionaire, United Artists Theaters, one of the creators of Comcast, Liberty Mutual. You know, he's a real captain of industry. Close friend of Ronald Reagan's, and a guy I used to hang out with. Okay. Doug Trumbull I guess it was the 1980s. Doug Trumbull worked for Marshall Navy back. Oh, this is they were trying to develop some kind of camera, some kind of super cinemascope camera, and so I met Doug. Marshall Navy flew me and Kim Barafato. This in the 1980s, I guess, was down to Hollywood to meet, to Doug Trumbull's place, and that's how I met Doug Trumbull through Marshall, and there's more to talk about Marshall Navy later on. But so, in any case, Doug Trumbull comes to NASA, and I'm sort of shepherding him around. There's a meeting at my place. In fact, where I am right now, Pete Warren, Doug Trumbull, Creon, other guys, and what Doug is trying to do is to get NASA to fund UFO research. Okay, because Doug Trumbull, being an optics expert, what Doug Trumbull did, he developed a mobile unit like a Land Rover with all this stuff, frequency shift that they could have, he could have measured the anomalous frequency shifts from UFOs that I'm talking about. With cameras, all the latest stuff back 10 years ago. Had all this his own money, Doug Trumbull's own money, a mobile unit, and wanted to have a whole bunch of these things to track UFOs. That's why he was there. Okay. So, all right. So what happened? Then what happens is they set up the 100-year Starship, 100-year Starship. Was being set up. And this was a thing to try to, a project to get to the stars, right? And there was an initial meeting, 30 people, Jack and others. I was invited, spotted with Peter Diamandis. Is it Peter Diamandis? Yeah, it's Peter Diamandis. It's Diamandis. Who's the guy who did the genetic code? Down in Southern California. I forget his name.
Watson.
Craig Venter. No, Craig Venter.
Oh, yeah, that one. Yeah.
Craig Venter. All kinds of stuff with the long, guy, the Rockefellers, all these. Oh, well, what's his name? All the hippie. Who's the hippie guy? The cat. Oh, in any case, all these, a lot of these progressive guys, a lot of these important people who are around Jerry Brown at the time, and now I guess a lot of these Democrat guys. In any case, they're there, but high techies, the techie people, Silicon Valley people. Okay, so there's a meeting. All right, they set up a meeting in Orlando, Orlando. This is now October 2011. And it's DARPA, NASA thing, an hotel. The general warden invites me to give a talk. He pays my airfare and my hotel, down to Orlando. And guess what? My paper is about UFOs. Low power warp drive, and metamaterials. This is October 2011. Okay, and metamaterials. And you can read about this. Sharon Weinberger. See now, Weinberger, she's a defense journalist in Washington, defense analyst, journalist. She's written a bunch of books. She writes, she wrote a BBC, there's an article on the BBC website about Jack Sarfatti, UFOs. So what happened was, I give this talk, and I'll tell you what the physics was in that talk. I give this talk, and guess who's there? Guess who's there? The same people. Eric Davis, Mark Millis, John Kramer, John Kramer, Doug Trumbull, and a whole bunch of people, about Doug Trumbull. And a whole bunch, and the Russians. Russians are there. Of course, they're going to be there, right? Not advertised, but the Russians there, Russian agents were there, right? And so what happens? I start saying that flying saucers are low power warp drive, and they're using metamaterials to do it. Eric Davis and John Kramer and Mark Mills, they all get very upset. They say, oh, no, we don't want to talk UFOs here. No UFOs. The article by Sharon Weinberg in the BBC tells all about the big, the big stink, the big mess I made by bringing, because they're all afraid of being late. Even though Eric Davis, we now know, Eric Davis, one of the big UFO guys, right? He's pretending he's not interested in UFOs. I'm telling the truth. Eric Davis is lying. He's like, Eric Davis is like Joe Biden saying, we won in Afghanistan. Okay. All right. Yeah. So, and then what happens? Doug Trumbull comes to my defense saying he thinks there's a legitimate, so there's a whole fight going on there. And the next day too, that Doug Trumbull's the only guy who defends me. All the others, they're scared. No flying saucers. Oh, no, because they're afraid they won't get any money. They're just trying to, they're afraid it's too crazy. All right. Okay, but then what I had, the equation I had then wasn't quite right. The equation I had then was G mu nu equals 8 pi G over C to the fourth. But then I had like the 1 plus chi E 1 plus chi m squared. I had like the modification of the modification. Okay, what is, remember, C squared? C squared is 1 over epsilon 0 mu 0. That's the vacuum, okay? And this is the modification. Okay, what this is, that's all from E plus E minus photon scattering. That all comes photons. I'll put a place to talk about the vacuum polarization, the earth electron positron. But I claim an inside material you have to include the real charges. Okay. Now the problem with this was this was not invariant. Although they didn't know that, the guys, they were just like going, oh, like this. I want to hear no UFOs. So they hear UFOs. Their minds close off. They panic. They piss in their pants. The whole thing. Okay, so there it was, and that's where it was until about 2019, and that's when Keith Wanza, who's an expert in he knows all this dielectric stuff. And he said, well, it's not invariant. That's a valid thing. And then I think it's not invariant. Then I found Medina Stephanie papers from about 2017 that came out, where they basically have the same tensor that Matt Bissa has, A, B, C, D. Okay, on this tensor. So I said, now here's the logic. Einstein's equation. It's a tensor equals a tensor. And there's a coupling here. that coupling has to be a scalar field. Because it has to be locally invariant. You see, a scalar field can be variable, can change, from X to X. I mean, I have a scale, I'll call it S. S of X not equal to S of X prime, where X is not equal to X prime, but it's still locally invariant. See, people don't understand. They don't understand, well, they don't understand tensors. They don't understand anything. See, what happens, if I have an X here and an X prime there, okay? In general relativity, the transformations are local transformations. I have like this. I have Alice. I have Bob. Okay. And what they're doing, their light rays are going, this is Alice's world, this is Bob's world. So photons are going, real photons are going to here, to Alice, and they're going here, okay? And Bob, Bob computes a tensor, I'll call it G UV of X. And Alice computes G U prime V prime at the same X, okay? But then the transformation is between these two guys here. Transformation is G mu prime V prime X, the same X equals X mu prime mu at the same X. I'll call this big X. V prime V G mu at X. This is Bob, and this is Alice. The transformations, see, people, here's the thing. You look at these relativity books and these people, these guys who are computing, they can do good mathematical work, but they're mathematicians, not physicists. They don't even know what they're doing, what it means physically, operationally. They don't know what it is. It's mathematics. But this is what I mean. Now, what about over here? Over here, okay? Similarly, photons have to reach, and they compute, they do the same thing for X prime. But the transformation, by the way, Alice and Bob have to be what's called local coincidence. Let me go to next. Einstein, you have to read Einstein. Whole problem. Alice and Bob, detectives, they're local coincidence. What is the basic physics problem in all relativity, whether it's special relativity, general relativity? You have two observers, Alice and Bob. They're using light signals, far field light signals, radiation, to measure something that's happening out there. Okay? And they collect their data, and they use the theory, they use relativity theory, the equations, which are like algorithms, like a Turing machine, algorithms to compute what are called invariants. And the tensors themselves have to transform in a certain way. So the objective reality are what are called the frame invariants. Frame invariants. The whole idea that physics is objective means that Alice and Bob, looking at the same set of processes of events, looking at them with light signals, then compute quantities from the theory. They get numbers, and the numbers agree. They get the same numbers, right? That's how they know they've done it correctly. That's what relativity means physically. And a lot of people doing relativity or teaching, they don't even know this. They don't go, they know how to do the formal manipulation without understanding what the physics of it is, what the physical meaning of it is. Okay. So that means in the case of here and here, I can have a scalar field X here and a scalar field, that same scalar field there. where S of X is not the same as F of X prime. But when Alice and Bob compute here, they're going to get, and they do a transmit, it's going to be S prime of X. I'm sorry, no. It's going to be S of X is going to be a local transformation here is going to go of S prime X prime, which turns out is going to be S of X prime. It's that the same numerical value moves over here rather. No, okay, I did that. No, I did that. See, even now I can do that. No, that's not right. Forget that. Forget what I just said. I said it wrong. Let me go with that one. What is it? It's X. Let me do it. Sorry, let me do it again. It's X prime. It's, I'll call it Alice and Bob. This is what I want to do. Okay, Alice and Bob, and but they're using light signals. Okay, now, so I have S of A. Here's it here. S of A at X goes to S of B at the same X. S of B at the same X, but S of B at X equals the numerical value S of A at X. That's what I meant to say. See, over here, they're the same. But if they do it over there, it'll be different. Here you're going to have S of A of X prime goes to S of B at X prime, which is, but that's equal to S of A at X prime. But S of X for any observer is not the same as S of X prime. See, whoops, back. This is a subtle concept because even people like Kevin Knuth, I think, I'm not sure Kevin, but James Woodward is very confused. He doesn't get this. A lot of people, they don't get this. They say, oh, speed of light has to be constant. Taking special relativity, uniform, they don't understand what a scalar field is. So a scalar field, and even I got confused trying to explain it to you, right? For a moment, I forgot, all right? Your scalar field, it's locally variable. It's not the same at different points in space and time, or different events in space and time, but it's locally invariant. In other words, if two different observers try to measure the value of that scalar field here and now over there, they try to measure it, they're going to get the same number because it's a local frame invariant. Although over here it's different, it changes. Now let's get back to what Einstein did. So what did Einstein do?
So it was a correspondence principle. He just wanted to get the vacuum solutions to match.
Yeah. So here's what Einstein did was this. Einstein had G mu nu in 8 pi and X. He doesn't know what X is, right? And T mu nu. But in particular, we go, the Newtonian limit is the zero, is the time component. 0, 0 is equal to 8 pi X T00. Okay? So what happens is, if you do the tensor calculus, G00 goes to, I think it's 2 del squared Newtonian over C squared. That's what that is, okay? And that has to go over, and Poisson's equation is this is equal to G, I think 4 pi. Yeah. It's equal to 4 pi G rho. That's the mass density. In fact, that's the mass density. Okay. So in order to do that, in order to get that to agree, if you do the math, in order to get to agree, if you take G over C,
you
take G over C to the 4th.
That's right.
Yeah, G over C to
He's got a C square. And
then because T00 is equal to rho c squared.
Yeah.
Yeah. Okay. So that's how we get it. So that's how we got it. But the C, it's purely empirical. The only thing you do need is an invariant. It's got to be an invariant. But this is a trivial invariant. Yeah, this happens to be an invariant, which is the same everywhere in space and all over matter. But there's no compelling physical reason for it to be that, because what it can be.
Yeah, I'm digging it, Jack. I'm digging what you're saying. And,
wait, just let me finish my argument.
Sure. Yeah.
Let me finish my argument. What it can be, all that's required mathematically, 8 pi c to the 4th g. This is for dimensional reasons, and then I'll have an s. I'm going to put an x. X t mu x. These are okay. Where this is, see, this whole thing at fixed x, see, this is what's important. At fixed x.
Yep.
Where the at fixed x, s is invariant.
Yeah.
So okay, but it could be different inside a material. It's different in different locations of the crystal lattice. It can be different, but it's still invariant. So this is still a kosher tensor equation. And now, okay, and now, wait, and now then the trick was, and now this is Keith Wanzer, okay, Keith Wanzer. See, he fixed my thing. So your equation, it's Z A B C D Z A B C D.
What is the
contraction.
of that?
It's just that way. Now wait, let me finish. I'm not finished.
Yeah,
No, don't interrupt me in midstream. I have a coherent sentence. I have to finish my sentence. Put a period there. Dot the i's and everything. Okay. So now, in particular, in a simple case, of a homogeneous isotropic material, okay? Keith went through everything, I mean, there's a lot of calculation. He went through the actual tensor, all the component. And in a simple case, S equals 1/2 epsilon 0 squared plus mu 0 over mu. It's a homogeneous. Any material, this is true for any material, homogeneous isotropic material. Now notice one thing. This is now Keith's discovery. Mu is the magnetic permeability. When mu goes to 0, this thing goes infinite.
Yeah.
Diamagnetic, okay, wait, let me do it again. S equals 1/2.
Yeah, I can see you contracted these things. I can't see you generating.
Mu 0.
Where do you get
Mu,
that?
oh, wait, mu goes to 0, S goes to infinity.
Yeah.
Mu goes to 0 in superconductors. The Meister effect, superconductors.
Okay.
Meister effect, expelling.
Yeah, it's a super diamagnetism. Yeah.
Okay, this is just a rough thing. This is that, I mean, it's not going to really be infinite. Okay, so now, but when S is big, so here's the main idea of warp drive. If G mu nu equals 8 pi G over C to the 4th S T mu nu, let's just just roughly, if S goes to infinity, for a fixed, keep G mu nu fixed, we have a desired warp field we want to make. A desired warp field, T mu nu goes to 0. That's the basic, simple math idea. It goes to 0. That's the basic idea of low power. Low power warp drive. Okay, so the point is, you're beginning to see that's the math of it. Now there's a lot more, because I'm leaving it. There's a lot more. It turns out is what's called the Hawking-Unruh effect. Basically, what the Hawking-Unruh effect says is that the distinction between real and virtual electric charges depends upon the proper acceleration of the detector. So that means the very nature of the quantum vacuum, the boundary between real and virtual charges, is contingent. It's not it's a relative thing. It depends on the absolute on the proper acceleration of the detector. So this means if you're calculating the coupling of electromagnetism to gravity, you have to include all charges equally. It's like a Copernican principle of charge. You can't only, the speed of light in vacuum is only the virtual electron-positron pairs inside the quantum vacuum. But as soon as you go to an accelerated detector, which is a transformation of general relativity, as soon as you go to that, what's a virtual charge for Alice is a real charge for Bob. It's like the electromagnetic fields, the way they transform too. Okay, an electrostatic field in the rest frame of a charge. When you go to a moving observer, it's like a charge in motion. It's like a magnetic field. All that kind of stuff. Okay, so the point is, in order to be consistent mathematically with covariance with the tensor calculus, you have to include this. You have to include what the S field does. The S field includes the real charges together with the virtual charges. In other words, this is like it's like a screening. It's like a screening factor, like screening.
Yeah.
It's like it's like Q squared over 4 pi epsilon R squared, the Coulomb force. But epsilon, instead of epsilon in vacuum, goes to epsilon in the material. It's very much like that, but that's it's a special case. This is a generally covariant version of that. It's basically the screening. It's what it's doing, what our S field does physically. It integrates in a consistent way the interaction of the input photons, real or virtual, with all the charges, both real and virtual charges, because that the boundary between what's a real and virtual charge, they transform into each other under general coordinate transformations. So you have to have this. So it can't be the speed of light in vacuum. That's stupid. It's totally stupid from almost every point of view. Okay, I'm going to take a quick break because I'm going to run to the bathroom and drink some water. Why don't you guys? Let's take a quick.
Get some water. Yeah.
Okay. Go for it, Jack. And then actually when we come back, we'll go to Jeremy Reese.
Talk with you.
Is everybody getting that? You getting that?
Yeah, and we're getting a lot of great feedback. Thank you for asking questions. And
we Jack and I, we were with his group, Joseph and a few others. They were digging at him. Jack was being his usual self, very how do I put it, very forthright. So he's pissing them off. But I'm beginning to see what he's saying there. This S needs to be there. Just because of this Hawking-Unruh effect, yeah, you need to bring all kinds of charges, virtual and real, under the wing of this effect, and it should be in relativity. It should be in general relativity.
This
And
is
it's
amazing
also-
stuff. Like nobody accounts for that in any equation.
Sorry, who's that?
oh, sorry, that's Lulu. Hi, Lulu.
Hi.
Happy Saturday.
It's not a happy
I
Saturday.
hope I did a good enough intro for September 11th. I didn't write
Yeah.
notes on that, so I kind of dropped
Yeah.
the ball.
So Lulu, what were you saying?
I said most equations don't include the detector, as part of it in any form. Not, and here, the detector is in motion as well. So motion does.
Like what they call fiducial, isn't it? Fiducial hypothetical test particle which tends to zero. I mean, they try to, as you say, try to take out the effect of any detector. Yeah. But
Good stuff.
I think the point Jack is making here, there are effects. The history of relativity is to do with astronomy, and you're dealing with, it just follows on from Newtonian cosmology. They're dealing with point masses. They're not considering anything happening inside a material. So it's totally legitimate in this century to be considering relativity inside materials. And then all the purists are saying, well, how can any of this be invariant? And Jack has explained how you can have something which varies, but locally is still invariant. So I concede on that. And then this whole idea of S, which I'd like to see the derivation. I'd like to know how he gets it from this fourth rank tensor, how he gets this neat S function. I'll have to look into the source papers of
Okay, now I'm back. So that
right.
is not, okay, that's the work of Matt Visser and his
Right.
group. The fourth rank tensor is standard. Apparently, oh, wait a minute. Apparently it goes back a long way. Somebody's found a reference, I forget, a guy named Doyle. This fourth rank tensor is well known to solid state dielectric type people. It's a standard thing.
Okay.
It's called a covariant. Yeah, it's called covariant. There's a whole bunch of books and papers on it. This is not Jack Sarfatti or even Keith Wanta. The fourth rank tensor susceptibility is, there's a literature, and it's experimental. I mean, it's engineering, it's electrical engineering, solid state engineering. Now, putting the way we could, the scalar field, the contraction, that's original. That's Keith Wanta and me. Doing, in other words, okay, let me say it again. Z, A, B, C, D, that's a long history, a lot of literature on that, okay?
Okay.
Saying that S equals Z, A, B, C, D, Z, A, B, C, D, and that G over C to the 4 goes to G over C to the 4 over S, that's Sarfatti and Wanta. This is Visser, and Medina, and other people. There's a whole bunch of, you can find that in the literature. That tensor is well known.
Okay.
Computing, what Keith did to compute that simple little form. Oh, wait a minute, but wait, I gotta tell you. So now, it turns out Jack 2011 at DARPA, NASA, Jack 2011, I had G, I had G, C to the 4th, I wrote down, N to the 4th. N equals index of refraction.
Okay.
Refraction.
It's not invariant. Yeah.
Okay. Now it turns out Wanza's formula is something like is actually reduces Wanza's formula at a certain limit. It's like 1/2 N to the 4th plus 1. That formula I showed you. So I was, and Keith says, Keith says in certain limit I was within 19% of the real. Numerically, if you tried to compute things, my original thing, just intuitively, would have been within 19% of the real result. That's okay. So I was on to something. I didn't quite get it, but that's the way things go, right? I mean, my intuition was right.
Jack, I gotta go soon, so I have a couple questions I want to ask
I was
real
going
quick.
to go to Jeremy next.
One was, why does the Froelich order parameter strengthen the coupling?
Okay, okay, but I think right now it's the Sarfatti intuition, educated guess. I can't regular, but what I think is going to happen, I think what's going to happen, you're going to have an e to the I psi, like things, something like this. E to the I psi, like in Keith's case, epsilon of epsilon 0 squared plus mu over mu 0. No, the other way. The other way. Oh, come on, stop. Oh, fuck.
And then the second question was, are the gravitational effects produced in the metamaterial with hyperbolic or parabolic solutions, or both?
Okay, wait, yeah, well, hang on, just a minute. Let me get back to where I was. Okay, here's the thing. What happened? Okay, look, you have a resonance. Let me get to here. I'll give you a more a better argument. Resonance. What a resonance is, you have things like one typical resonance. You have omega squared minus the resonant frequency squared plus I gamma omega, and let me just normalize it. I'll call this omega omega r. You have like a resonance like this, right? Gamma. Okay, now gamma is the dissipation, right? Gamma gamma is line width, right? Like the line width. Gamma. Okay. So what happens is, okay, so what happens at resonance? At resonance, omega goes to omega r, okay? And what happens? This goes to omega r over gamma times I. That's the Q of the oscillator, the quality factor of the oscillator, right? So what you want to have this thing as, and that's the peak. The peak height is increasing, right? The peak height in this factor here, the peak height is going as Q. So what happens? You want to have as small dissipation as possible. What happens to the Flourlic condensate? It's a long range coherence. Again, the Flourlic condensate is making gamma smaller. Is what I think. Okay. Also, there's another reason for it. Okay, there's several reasons. I'm doing forensic. I'm doing detective work, police work here, because we have other evidence. We have Giovanni Modenese, and this guy Podkletnov or some Podkletnov. They are claiming gravity anomalies in superconductors. So apparently, and then Modenese has papers showing that if you have macroscopic wave functions, you have order parameter. In this case, it's equilibrium. It's not Flourlic. It's the equilibrium. The Flourlic is simply the non-equilibrium version of this. Okay.
Right.
And
he said that there's a large diameter superconductor disk, but there's also a pulsing frequency that's part of it. Apparently.
yeah, which is the pump, like a pump, right?
Yeah. The pump
yeah.
states. Yeah, it's like excitons.
So he said, so I have that kind of empirical evidence, you see, because this is basically a Flourlic. Okay, if he's pumping it, it could be non-equilibrium. It's basically a Flourlic. It could be a Flourlic condensate, technically speaking, because it doesn't happen if he doesn't pump it, right? You have to pump it like a laser in order to get it to happen. Okay, and by the way, this gets into the weapons. You know about the gravity impulse. You know about IgG. They're claiming that here's a superconductor, zap, flattens metal. Well, I mean the impulse. They're claiming a gravity pulse travels and actually causes an effect. Okay. Remember you had the guy John Hutchinson. Maybe it's related to that. That is John Hutchinson seeing all kind of weird. He has these huge voltages, huge electromagnetic pump fields, and he gets the metal. The metal is collapsing. So maybe Hutchinson is generating somehow, like Thomas Edison or like Tesla, is generating these huge gravitational pulses. And then you also have Matt Bissa. They has tractor beam, it's called tractor, repeller, repeller, and stressor beams, gravity beams. Beam. He has solutions. He has the general relativity, but without my S field, they're weak. They're not strong. But he has a little picture of a flying saucer, zapping, flattening a cow. In his paper, he has a little cartoon of a little green man in a flying saucer shooting his gravity beam weapon and flattening a cow. And by the way, Brandon Fugel and Travis Taylor in their Skinwalker Ranch, History Channel, they have like a flattened cow that's below the ore, below the hovering object that they claim. I mean, this is pretty funny.
Do you
Well, this
think
is
that
Huh?
they could have come across some of these waves so they can make these beams? Are they using electromagnetic energy or something to do this, or lasers or anything, or how would you generate such a beam?
Are you talking about
Not the Skinwalker Ranch, but I was talking
Oh,
about
no, no,
Matt Visser.
They're not using anything. They're just observing it. It's high strangeness. They don't have any equipment. All they see the dead cows.
Is it possible that, like, those? Have you heard of the light craft, like Lake Marabou technology that they were working on with NASA and stuff? And there's some patents by Kevin Kremer about shining, like the supercavitation stuff. Would that be able to, like, if we did a laser, could we affect the space time by at all with the high powered laser, or would that not be enough?
Well, if you shine the high powered laser on the right material, you might induce a resonance in the material that would do it. But the thing is, if it's too high power, destroy the material, so that'll be counterproductive. So I don't know.
What about doing it in vacuum?
Well, no, in vacuum, there's nothing there. This is everything. Not what I'm talking about.
Everything you're talking about is inside of.
Depends upon the susceptible. Depends on the electromagnetic, on the response of the material, the resonant response of the material.
What
applied electromagnetic field that's going to generate a strong gravitational field. In other words, what I'm talking about.
What about other thermal dissipative modes? Like, what about other dissipative modes? Sorry, like for example, thermal phonons.
Wait. Let me. Well, yeah, wait. So I have. What do I have? I have an EM field, EM input. I have the metamaterial. And I have a gravity output. The metamaterial has an S field, and basically, when the S field gets big, well, I'm not going to say infinity because I'll just say when S, and I haven't included all the imaginary parts, or just roughly. We want this when S greater than 1, weak. EM, creates strong gravity. And if this is a beam, in the far field, this can be a beam. It's a weapon. This could be a weapon. Directed energy weapon. High frequency, there was all this stuff that Paul Murad and all these guys were talking about, and was shut down. I was actually this was a Jason meeting. Jason meeting in 2008. I was there. I was at this meeting, but I didn't know. See, I could have saved that meeting. The Jasons, there was I forget the names of these guys. They all claiming, these high frequency gravity beam weapon possibilities, and they were totally shut down for the same reason that space time was too stiff. In fact, that's probably how I got the idea. That may be, that may have stimulated my thinking about this. Basically, they were all shot. That Paul Murad was made to look like an idiot. Says, when you put in the numbers, space-time is too stiff. You're not going to get anything. You're not going to get anything that could be detected. Okay? They were all, the arguments against all this, Jason, you know what Jasons are? Does everybody know what the Jasons are? Do you know what the Jasons are? The Jasons, DOD, Department of Defense, DOD, elite physicists. Solving, problems for the defense, for the Secretary of Defense. When I was a graduate student at UCSD in La Jolla, for a while, I worked with Keith Bruckner. Keith Bruckner ran the Jasons, the Department of Defense. So I was at a few Jason meetings back when I was in the 60s, when I was, a graduate student. And Pandolfi, Ron Pandolfi, CIA, ran this Jason meeting and had me down there. I was down there because of Pandolfi. Okay, but that whole thing, they were using Geodesics the 4 vacuum. See, and that's what defeated it. In fact, there was even a meeting at MITRE. They debunked the entire concept because of Geodesics the 4 vacuum. Okay, so I think that subconsciously, now I think about it, that subconsciously led me to the S field. So now everything that they were claiming, and now because of that, gravity. Okay, here's what I'm claiming. Any military guys listening? You schmucks, you military schmucks. Look. You know what Tic Tac can do to your fucking F-18s or your MiG-29s or whatever you're going to throw at it, your Su-35s? They can shoot a Matvisa stressor beam with a metamaterial gravity laser, from the Tic Tac, and it'll spaghettify. It'll spaghettify your missile coming into it, or your jet fighter, or your aircraft carrier. It'll just be like the aircraft carrier fell into the singularity of a black hole. That's the kind of technology you're up against if you don't wake up out of your, and listen to what I'm trying to tell you.
Well, Jack, if I could mention really quick, what you just mentioned about the meeting with the HFGW, Gary Stephenson, and he might actually be in the conference. He had said exactly the same thing. He had said, and this was when you spoke earlier at APEC, Gary had said, if we had known about the metamaterials back during that meeting. So he said exactly the same thing you said. I just thought I'd put that out there.
Well, because it's obvious now that we didn't have that idea yet. We didn't have this idea of changing the coupling. And the reason I got it historically was because it was stupid, because I didn't, Keith Wanzer is, when he writes the paper, will explain the history of this is into because of the slow light experiments in superconductors. Oh, that's the other thing. See, superconductors, because the resonances, they slow down the speed of light. That's part of what's going on here. It's more than that. That's part of what's going on here. Okay, so that gave me the idea. That was just naive idea. So, well, the superconductor, that's a for the condensate, also like a superconductor. If that slows the speed of light, that enhances the coupling. So that was the original idea, and now it's gotten more, more rigorous because the tenses all that. But that was the original idea. Okay, and I think if I hadn't gone to that Jason meeting, if CIA's Ron Pandolfi had not invited me to Jason meeting, I might not have gotten this idea. So it's all kind of like, it's all being programmed, programmed from the future, destiny, it's all, because remember they said, I don't, and when I was a kid of 13, the alleged conscious computer aboard the flying saucer said that they were programming me to create their technology. And not me, others too, like Al Puthoff. Well, the others who I begin to meet in 20 years, they were also part of it. It's a whole group of us they selected. We were kids in the 1950s. Okay, so maybe that's what's happening. That's what I think. That's what I think personally is happening. Because there's too much woo-woo, weird, really high strangeness stuff in the sense of Jacques Vallée paper that's really going on here. This is not coming out of the, there's a whole context here. I'm basically channeling this information.
Tim, when are we going to get Ron Pandolfi on? We got to get Ron Pandolfi to come on too, man. That would be great. Thank you, Jack, for that. That's really interesting history. I think I heard about Jason years ago, but thanks for reminding me about that. I'm going to have to dig into that a little bit deeper. That's super interesting.
Yeah.
Wonderful.
Yeah, you should invite Ron to talk. I don't know. Yeah. Okay.
Yeah. Well, so let me ask and see who else has questions. And so we're coming up on just about 3 o'clock Pacific. So Jack, that's close to 3 hours, sir. I don't want to take too much of your time.
If somebody has an intelligent question, I'm having my little Johnny Walker here, and that gives me an added energy. It's the first drink I've had. This is the first drink I've had in over a week because I had a booster shot. I had to have a booster shot for the COVID vaccine because I'm flying to London in a couple of weeks, about 2 or 3 weeks. I'll be in London till the end of the year. So yeah, in order to fly, you have to get these damn shots. And
Oh,
they need-
cheerio. What I was going to say, about another question that I about the phone, the thermal phonon modes, thermal phonons. Would those be contribute to gravity effects, or would energy be
Oh,
expended?
if you mean if you have like a Froelich condensate of phonons, yeah, they might. Yeah, piezoelectric, yeah, all that. Oh yeah, in fact, I remember now. That's a good question because there was a lot of interest in that when Joe Firmage set us up with several $1 million in 1999 to 2000. Only didn't last very long because he lost his money. But there was a guy there. In fact, the same guy. I'm pretty sure it's the same guy whose father was a friend of Kurt LeMay and all the UFO guy. That guy was also talking about generating tractor beams using pump piezoelectrics, right? So, so there might be some, there may be something to that. Oh, I should also mention that Hal Puthoff, and in his lectures, shows that slab, the bismuth, it was a bismuth, magnesium, or manganese, or something like that. Okay, that slab that allegedly retrieved. Well, it turns out bismuth is highly diamagnetic in equilibrium. God knows what happens when it's pumped. It's tied, so that ties in too. So there may be something too. These are just clues. Like we're now it's the police. It's a mystery. It's a police mystery. Somebody's been killed, and we have little clues. We're piecing together clues, right? We're doing forensic analysis here, combined with basic physics.
I like it.
Yeah. So any more questions?
Yeah, actually, let me go to Will Riken next. Will, go for it, sir.
Yeah, in one of your things, you talk about pumping photons. Now, what I've seen in your previous presentation with your writings, it seems that you're looking at up conversion. I was wondering if you've considered down conversion, or am I confused about this?
No, wait. Try to. The audio coming from you is not that good. It's like, are you on a cell phone?
No, actually, I'm at my computer.
Okay.
Oh, yeah, he's in Japan. I'm sorry. That's.
Can you, Tim? Do you understand what he's saying? Can you translate?
Yeah. So he'd said that when he's reading through your writings, you were talking about up conversion, and he was wondering if you'd ever considered down conversion.
I don't remember when I'm talking about up conversion. It means up
photon interaction.
That's like nonlinear optics. So what does he mean by down conversion?
Yeah, he was saying photon. Let me see. In photon interactions, so it could be nonlinear objects. Yeah.
Well, nonlinear optics is going to play a role for sure, but I'm not sure what the question is. I mean, nonlinear effects will be important, definitely. Up conversion, they may all be important. I don't.
Okay.
I'm not sure what the question is. Is non well? If the question is nonlinear optics going to be an important thing? Probably yes. When you're doing the weapons applications, maybe when you want to generate, the tractor beams and the repeller beams and the stressor beams of Matt Visser, I could see there might be converting a high power far field radiation laser input into a gravitational. Yeah, that would make sense. Roughly, that makes sense.
Okay.
I mean, you're probably going to need, you're going to need nonlinear effects for sure. For sure. So I said, roughly speaking, I'd say yes. Why can't I get this now?
Thank you. Let me go to Kate next.
Oh, hello. First off, this is absolutely amazing. I was just wondering, because you did briefly mention that Jim Woodward didn't understand everything, if you had done any research into his Mach effects drive, because I know he's having more success with that, and just what your thoughts are.
Well, my thoughts are this. Let's suppose everything Jim says is correct. Okay. it's still not going to be that helpful in terms of space exploration, because it's an impulse drive. It's just like it's like an ion drive without the ions being spewed out. It's like a propellantless propulsion, but it's off geodesic. There's G-force, and it's still going to be very weak. It's still going to take you a million years to get any place, and there's going to be time dilation problems, and it might be useful to get to the moon or to get to Mars. Okay, that's assuming it works. But now, Keith Wanzer, who is a full tenured physics professor at Cal State Fullerton in the same department as Jim Woodward. Actually, no, Jim Wood. Got to remember, Jim Woodward degree, his PhD is not in straight physics. It's I think it's in the history of physics and philosophy or something like that. So he's kind of partly a self-taught experimentalist. And Keith Wanzer, who's a real tenured experimental physicist, worked with Joe Weber and all that stuff, has found what's wrong. He found flaws in the experiment, the actual experimental. So what I'm pretty sure Keith and even Eric Davis, who we seldom agree with him, but even this, basically what Woodward is seeing is probably just a spurious, systematic error artifact, because it's so small. Even if it was real, you couldn't scale it up to anything significant. And even if you could do it, even in the best of circumstances, it's not what we're talking about. We're talking about warp drive. It has nothing to do with warp drive.
Yeah, I was just curious because he has made much increased the effects of it, and it's much better. But you think there's just no way to alter it to really make it go, or for
even if he did make it go, it's not going to help us. It doesn't explain the Navy observation. It doesn't explain the military stuff. See?
Yeah, no, I agree.
Okay.
I was just saying, is there a way to use any existing human tech to take us one step closer to alien tech?
Yeah, that's what my talk is about. Yes, what I'm doing.
Yeah, of course. Yeah. But that's why I was just asking what I understand, and that's why I'm very grateful. I was just seeing if there was any correlation between potentially any of his work,
I would say that Jim is a nice guy. He's a modern day Don Quixote. He's chasing windmills. He's seeing giant windmills, but it's noble. He's noble, right? And Halford is his Sancho Panza. It's right out of it's a modern day Don Quixote. And that's true.
Yeah, and thank you as well, Kate. Let me see. So who else has questions? Who has questions next?
Is that it? I think we lost everybody, but I think just like Socratic dialogue.
Yeah.
Stay up all night and drink them under the table, and they don't.
Jack, I sincerely, I appreciate all the time that you've given us. I just don't want to overwhelm or wear you out, and that's.
I'm fine. But the thing is this. Okay, what I see this as being, the scribbles are hard to understand, but this may be a basis if people think about it and go back and look at the slides about it, and then want to come back and ask more questions, detailed. We could get into the nitty gritty. And I should say this, what's reprehensible in terms of Eric Davis, Hal Puthoff, all those guys, Christopher Mellon, is that they're not engaging me in a debate on these topics, on these detailed technical things. See if I'm wrong, debating. They're afraid of me. They're afraid to talk to me and to, especially Keith Wanzer. Keith Wanzer, serious. He's a serious, he's a heavy.
Well, we'd love to have Keith on too at some point.
Yeah, well,
and I know he's, yeah.
Yeah, he has things he has to deal with. But the point is that that Hal Puthoff and Kit Green and Louis Elizondo, they have the ears of the Pentagon. They get on Tucker Carlson. Okay, they're talking to the senators. They're giving them bad information. This is the intelligence. I want to get back. 9/11 was an intelligence failure. 2021 is an intelligence failure again, because people like Elizondo and Chris and Portoff and Eric Davis, and they're not letting my information get to the people who need to know my information. So at least to debate it, you have to have a due diligence. You get all sides of the story. They're showing their one side of the story. Now, Ron Gaddafi thinks they're doing it for financial reasons, political finance. They're trying to get money. I don't know. You could ask Ron Gaddafi. I don't know what that's all about. But Gaddafi has very strong opinion about these people, and so does John Warner IV, who is the cousin of Chris Mellon. So there's this thing, and then we have this guy Randolph Stone, who's in the Inspector General's office of the Pentagon, who's supposed to be investigating all this. He hasn't called me yet to get he hasn't spoken to Keith Wanzer. They haven't done their job. But the Russians are very, and guess what? I have to mention again, I got several hundred, 300 to 400 Iranian scientists who are tracking all my stuff on the social networks, on the physics stuff. So the Iranians are into this. The Russians are into this. And our guys are, what are they doing? They're doing nothing, as far as I can see. They're bullshitting. They're hiding.
Yeah.
They're pretending it doesn't, they're doing with the UAP problem what they did with Afghanistan and Iraq. The military, the Afghan military, they're great. And they're lying. They knew they weren't. Did you hear on C-SPAN? There's some good shows on C-SPAN the last few days. This guy wrote a book, Washington Post. So I normally don't try. The Washington Post guy wrote a book, The Afghan Papers, showing how Don Rumsfeld, who actually sort of worked for Don Rumsfeld lied through his teeth in 2003 about what was going on. They're all lying. They're lying. Even Obama lied, and now Biden is lying. That the Pentagon, the Lloyd Austin, Secretary of Defense, and Mark Milley, that they knew that the Afghan army was a paper tiger. Most of these guys in the Afghan army, they couldn't even read. They couldn't count. They didn't know they couldn't count how many cousins were in their extended family. They couldn't tell the names of colors. That's how primitive, and they were like cavemen, okay? They're very low-level mentalities. Was the rank and file of the Afghan army.
Yeah.
So, I'm saying, as an analogy, the same thing's happening now with the UAP. We have stupid people, incompetent people in charge, and they're not doing due diligence. They're not doing their job. Well, the Russians are doing it, I'm pretty sure. Okay, and maybe even the Iranians.
So actually, Will and Jeremy, if you are open to taking more questions or having discussion, Will and Jeremy had more questions. But it's up to you, sir. It's up. Okay. Do you want me to? Should I turn off your screen share?
No, because
okay.
The only way I can answer the question is to draw an equation, probably.
Okay.
I can ask real questions. A few words. Words are not enough. Look, physics, mathematics is the language of physics. If you can't speak the language, you can't understand this shit. You have to know.
So I think
it's like I can't read.
I think that's going to answer my next question. I had a question in the chat. This is not from me. This is from my viewers. I get a lot of people on the live chat, and they I think this might answer it for them. But I want to get your official statement. What are your opinion on Bob Lazar?
Bob Lazar. I don't know. Bob Lazar has a checkered career. He's been in trouble with the cops too. Bob Lazar may believe what he's saying. Bob Lazar, at the very best, was a very low-level technician at Area 51. And this goes to George now. Anybody who takes Bob Lazar's stories of Element 115 seriously is a fucking idiot. Stupid, okay? Just a stupid idiot, a schmuck. Yiddish, just a dumbass.
He's just a senior staff physicist at Area 50 at S4 though, and where's his math?
Who's a senior staff physicist?
S4? Bob Lazar claimed to be a senior staff physicist, but he has no CV. He has no curriculum vitae, no math.
But here's the thing: Bob Lazar is serving a useful function, because anyone who takes Bob Lazar seriously should be immediately rejected as a fool, as an idiot, as a physics idiot. Okay? Doesn't know shit from Chinola. I mean, really so fucking stupid. I can't, I mean, it's like a Mel Brooks. Oh, yeah. You know what it's like? It's like Professor Erwin Corey. Do you ever watch Professor Erwin Corey? His shtick, his Yiddish shtick, you know, and, I mean, it's a total fake. I mean, it shows how, and by the way, people like Lazar give ammunition to people like Michael Shermer, the skeptics. They realize how stupid this, how ridiculous it is. And the people taking him seriously, how stupid they are. I mean, okay, so that's, I mean, you know, it's a shock. It's funny in a way. Okay, any other questions?
Sorry, could I just ask a question quickly
Yeah.
to Jack, Tim? Yep.
Yes,
Please.
yes, go.
You said you felt a calling, and we all feel a calling, and sometimes when things pop into your head, it's
Yes.
so perfect, it's like it's been planted there. Do you think
Yeah.
we have a hive mind? Is there anything to suggest we have a hive mind?
Oh,
and it might
absolutely,
be-
yes, of course we have a hive mind. That's, oh yeah, okay, let me get it, yeah, okay, good, let's see, am I getting it? Wait a minute, what am I doing? What am I, okay, yeah, hive mind, yes, okay. There's my pen. EPR, signaling. Okay, explains not only consciousness, this explains all the paranormal. Ugh. Normal, you know, telepathy, you know, the whole explain, yeah, and the hive mind. Yes, I mean, we're getting, yeah, I mean, channeling is real. By the way, EPR signaling does not happen in quantum mechanics. This is, you know, QM forbids EPR signaling. Okay, but PQM allows it. Let me make it allows EPR signaling. And it's PQM action reaction. As explained by Sutherland. 2015. Just go to the archive. But it's the same way, in the same way, special relativity forbids gravity. Forbids gravity. See, it's an analogy. I'm making an analogy here. Gravity is not possible to understand in special relativity because space-time is infinitely stiff. Because space-time infinitely stiff in the limit of special relativity. Okay, and so you need general relativity where you have the coupling. You know, it's fine, but it's still too. This allows you to bend space-time, but very weakly. It's too weak. So that's why I need G over C to the 4 to the S, where S gets big. You know, to that softened, that allows us to control the gravitational field. So yeah, so the hive mind, definitely. I mean, remote viewing. Well, you know, you have that's a remote viewing. See, it's all tied in. CIA, SRI, Hal Puthoff. Who's the big shmiya, the big macha, the top banana in remote viewing? It's Hal Puthoff and Russell Todd. Who's the top banana in UFO research for the government? It's Hal Puthoff. It's the same guy. UFOs, paranormal, Pentagon, DOD. I mean, Hal Puthoff had the highest security clearance. Kit Green, who's a CIA guy, right? Kit Green told me that Hal Puthoff had among the highest security clearances of anybody at one point in his career. So you have who's the spokesman? Who's the senior statesman, the great eminence for UFOs in the Pentagon is Hal Puthoff. Who's the main guy who organized the CIA experiments when I met him in 1970? Is Hal Puthoff. It's the same people on the same stage all the time. Doesn't that tell you something? You know, if you have any ounce of detective ability, Sherlock Holmes. Okay, go ahead. All right.
Do you know anything about, sorry, just to cut in, do you know anything about the I think it's a tabby stock?
The who?
Or is it not that? It's Denmark Hill in London, Maudsley. Do you know anything about that
Who?
connection? The Maudsley Hospital, Denmark Hill in London, connection with Timothy Leary.
Well,
MK Ultra. Do you know all about that? Do you know anything about that?
Well, no,
There's
okay, if you look on YouTube, on my channel, look at my YouTube channel. There's a video by Kim Burafato, a short video, in which she talks about a lunch that I had with Tim Leary back in the, I guess it's the 1970s, late 1970s in North Beach, San Francisco, where Tim Leary says that Jack Sarfatti, to me, I'm his heir. I'm going to carry through his space migration, intelligence increase, life extension. Yeah, I know Tim Leary very well. I stayed with Tim Leary in his Hollywood, in his Beverly Hills, house back in. I had Tim Leary's down at Esalen, but he got out of jail. Yeah, the whole history. I got a whole history with Tim Leary. Yeah, I know him I knew Tim Leary, and Tim Leary writes about me in his books. And look at Robert Anton Wilson books, right? Yeah. So, but I don't know about the hospital. What is this? Is this a hospital they were doing experiments?
Yeah, it's got some connection with MK Ultra, I heard.
Oh yeah, well MK, yes, well yes, I was part of MK. I mean, I was part of MK Ultra. I was like a subject. I was a kid. That's MK Ultra because one of the CIA officials who supported my work was an MK Ultra guy. Was Harold Chipman. Harold. Chipman, R.I.P., CIA Chief of Station, Cold War, Germany. He was a real OSS Bill Donovan type. Chipman ran MK Ultra in San Francisco. I guess back in the 1950s, maybe 1950s. Yeah, well, okay, Leary told me, here's what, I can tell you a lot about Tim Leary. Tim Leary's father, Tim Leary was born, Tim Leary was born at West Point. Okay. Tim Leary's father was an Army officer, was the West Point dentist. This is directly from Tim Leary now. When I was in Beverly Hills staying at his house with my girlfriend, Jenny Stapleton at the time, in the late 1970s. Tim said, his mother was a beautiful woman. I mean, Tim's a good-looking guy, right? Tim says his mother had an affair with General MacArthur because MacArthur was the superintendent at West Point. This is like, back in the 20s. And Tim claims to be the bastard son of General Douglas MacArthur. To me, he said this to me. Okay. Yeah, now there was a guy there. Okay. There was also a guy, an English guy. I'm glad. Okay, you're bringing back memory. There was an English guy, had something to do with Marvel Comics. One of the creators of Marvel Comics was there. Some guy from London who claims he turned on a lot of the royal family, people in the royal family on LSD. Okay. So that may have something to do with the MK Ultra. But Tim said that, see, I first actually met Tim Leary back in 1960. I was a graduate student in physics briefly at Brandeis, and I was also then worked for the CIA contract at MITRE Corporation. This is around 1960. And I somehow was, Tim Leary wanted me to be part of his first LSD experiments at Harvard around 1960. Okay. I was very straight. I didn't do it. But I was with Tim Leary and Aldous Huxley. When Aldous Huxley gave his MIT speech, Doors of Perception at MIT. Okay. He was there. Tim Leary brought Aldous Huxley over. I don't know if you know that. This is back in the early 60s. Okay. And, but Tim told me the reason he got into LSD, because he was part of them. He was a Harvard professor at the time. And he was asked by the CIA, and it's a Frank Barron, a guy named Frank Barron, who I also knew, Frank Barron, who I think actually, Nick Herbert actually knows Frank Barron, because Frank Barron lives around, I don't know if he's still alive, but Frank Barron was in Santa Cruz, the same place that Nick Herbert was at. And okay, Frank Barron. Is it Frank Barron? Enlists Tim Leary. Leary into essentially MK Ultra, CIA. And so that's where the CIA supplied Leary with the LSD, the experiment. Leary wanted me to be one of the kids, students taking the CIA LSD. I didn't do it. But Tim took it himself. And that changed history. The rest is history. And he went rogue. Okay.
Wonderful. Well, Jack, if it's okay, let me go to Carl Cartesian next.
Sure.
Carl, go ahead, sir.
Thanks, Tim. Jack, this is fascinating, Dr. Sarfatti, I should say. I have a couple of questions. I just want to prioritize them in something that's my level of interest. Do you know if this future AI from the Tic Tac is still in communication with anybody like Hal Puthoff or somebody within the government?
Well, I don't. How would I know? All I know, the question is, are they still in communication with me?
Yeah, even better. Yeah. Are they? Yeah.
I'm not getting phone calls from them, but all I can say is that these physics ideas, I start writing, it's like automatic writing. You know what I mean? Automatic writing. I just, it's like I'm just watching myself write the damn thing. In other words, I'm just the medium. The message in the medium wasn't. Who's the guy from Canada? Marshall McLuhan. Well, the medium is a message. No, so I don't know. So, but what could be is that I was in. Okay, now this does get interesting. Okay, I'm glad this. What's called EPR. Einstein EPR temporal signaling, which ties in a little bit with Frank Wilczek. I can't, it's a Czech name, Wilczek, MIT. He's Nobel laureate, time crystals. Okay, here's the thing. Where with this technology, you can implant information in the brain, okay, through entanglement, like entanglement of the microtubules in the brain. You can implant information and it will be triggered to go into consciousness at some time in the future. They're actually doing experiments with this atomic, this is a real thing now. If you go, if you just look on the archive and look at, quantum entanglement across time, okay?
That's not neuro-linguistic programming.
Well, that's another thing. This is much deeper than that.
This is like implanting a thought and then triggering it later.
They're doing it physically, they're doing it with physical fields. They're not doing it necessarily by hypnosis. Yeah, that can be done too. I'm not discounting that. But I think what I'm talking about is a different, it's a finer, it's a more subtle technology. It's an it's a physical electromagnetic technology of some kind.
Why do you
Okay.
think Hal is so fascinated by Uri Geller? Sorry, I don't mean to interrupt.
Yeah, well, the same as that. Yeah, well, because Hal is one of the guys. I mean, Hal's a contact. He actually told me he had some weird experiences about the same time I did. Okay, as a kid. Hal's a little bit older. Hal, I think, is three or 4 years older than me. And by the way, Uri Geller had his contact experience at the same time I had mine. In Israel, he had his in Israel. Okay, so we're all connected. I know Uri very well. I've spent time with Uri in London, here in San Francisco, and so we're all connected. We're all part of the hive mind. Yeah, okay, Remy, you're right. It's a hive mind. We're all part of it. That's just what they said. You'll begin to meet the others in 20 years, and you're going to create our technology. Now, I'm having some political, ego differences with Eric Davis and Chris Mellon and Hal Puthoff, but we're all basically, we're just arguing over details and how to do it. We're all in the same paradigm that it's real. We all believe UFOs are real. Paranormal is real. High strangeness is real. And we're now arguing on how to dot the I's and and put in the periods on the details of how to get it done, the tactics. We're having tactical disagreements, but we have strategic agreements, including the military threat. Okay?
Could I ask one more question, Tim?
Yeah.
If you don't mind.
Yeah, go for it, Carl.
At the start, you talked about, whether or not those videos are real, you've seen it. And now you can imagine a solution. And that's really inspiring, I think, to a lot of people.
Yeah.
Whenever I look at those videos, I immediately think of a type 2 superconductor that's quantum locked onto an electromagnetic field. And that they can operate freely orientated, move laterally and vertically. And I just see this absolute parallel.
Yes. Because here's the one thing. Here, look, here's a Tic Tac. Okay, it's the metamaterial surface. I'll call it meta surface. And I've been picturing it's surrounded. Okay, let me do. And then also it's like this. Well, just imagine it's all filled in. These are quantized magnetic vortex rings. Okay, where mu is going to 0. So they're also creating gravity. So, and it's converting the B field into the gravitational field, the gravity field inside here. And this is kind of popped into my mind. This is like in type 2 superconductivity in type 2. You have these, these are the Abrikosov lattice. Okay, so I'm thinking something like this is the way they control it. You're controlling every vortex ring here, controlling the magnetic field, and you're controlling the phase. You can have an anti-gravity. Okay, you can have, well, maybe you can have these rings here. They could have cosine of theta negative. So, I should have just used. Wait, let me just change the color. Let me change the color. No, I'll change the color. You can have these here. You can have the cosine. The cosine is negative. So that's anti-gravity. And here the cosine. Here the cosine is cosine theta is positive. That's gravity. So that's your warp drive. That's your anti-gravity warp drive. I think it's going. See. The space here is contracting, the space is expanding, and here you're going to have a redshift. This is a gravity redshift. That's gravity blue shift. If the UFO is if the UFO is, see, I'm getting all these details, and these assholes, Luis Elizondo, these guys, they're not engaging me on this to try to figure it out. They're not being constructive.
This is absolutely amazing. I just please continue. This is great.
Yeah. So you can have this is Skinwalker Ranch. I don't know what happened here. Skinwalker Ranch. They're seeing this orb here or something, and here's Travis. Travis claims he got Travis Taylor. Travis Taylor claims he got sick. It's hovering because this is all this is the the anti-gravity. So it's ionized, the anti-gravity, blue shift. Why is it doing this? It's getting him sick from radiation. Okay, when the thing hovers, it's got to have the vortex rings that are creating anti-gravity here to keep. That's the lift. That's the anti-gravity lift. Okay, in order to keep it at a fixed distance in the Earth's gravitational field. So okay, so what were you asking? Go back. Yeah, so I think this when you said type 2 superconductivity, it's funny because I've been thinking type 2 superconductors are going to play a role. Well, the analog, they're not. It's going to be. You don't need cryogenics. You don't need low temperature. It's going to be the Froelich room temperature condensate analog to type 2 superconductivity. Everything you could do with low temperature cryogenic superconductors in thermodynamic equilibrium, you can do at high temperature, at room temperature, using pumped Froelich condensates. Okay, that's why I think because you definitely want, you can get diamagnetic Froelich condensates at high temperature, non-equilibrium, and with Wanz's formula is when you get small, the gravitational amplification effect gets bigger because it's 1 over mu squared in the denominator. And even the stress energy tensity electromagnetic field also has mu's in the denominator, so it gets even more amplified. So so I think I have a feeling. Why did you say type 2? What made you?
The reason I said that is I've seen videos of type 2 superconductors.
What's that noise? What's the noise? Hey, Tim, where are you? You have to mute somebody.
I'm sorry about that. Yeah, it looks like.
What was that?
It's banned by somebody.
Okay, and
But is it somebody going crazy? Yes.
I'm you know what, I'm not sure, but I just removed them. I did mute them and they kept unmuting themselves. Maybe they were hitting their button. Please accept my sincere apologies.
Oh, I did. It looks like some crazy woman she's got a bear. Is this Adept monoatomic alchemist?
Oh no, this person's already gone. Actually, it was someone named John. So.
Oh, okay.
Yeah.
Okay. Sorry, monochromatic alchemist.
No, that's my fault for missing that. I was using the restroom.
Okay.
No, so to go back to the original question, it was about type 2 superconductors. The reason why I've been thinking about it is I've seen videos of a super cool type 2 superconductor, operating free of gravity effectively, that's quantum locked, that can operate and move at any orientation.
That's just magnetic levitation. It's not what we're talking. It looks like it, but it's not.
It looks like that, and that's why it's an analogy, and that's why I kept on thinking that.
Yeah, I'm talking.
The same thing.
That's not actually changing the gravitational field.
And that was my next question, which is, have we any evidence that UAP are actually creating gravitational lensing or warping gravity?
Oh yeah, of course. It's all over. Now, okay, now there was this guy. There's this guy. Let me change this.
And I can try and find that video. There's a Puerto Rico video, and I think that's the one Jack wants to talk about.
No, I'm talking. Why is this doing this?
Yeah, it's interesting. It's on thermal that we see the distortion.
Okay. Yeah, no. Okay, there's a guy named he had a website, UAP theory. Whoops.
Yes.
Wait, there's this guy. Okay, now I got it. This is an interesting story.
No,
There's
this is great.
This is guy, his theory.com. This guy, I forget his first name. And I'm not sure if I ever knew his last name. So I think that Tim, you know who he is, right? I think Tim knows who he is.
Yeah. And he just felt what he had told me was he took the UAP theory website offline. I have a copy of that. I think I sent you a copy of that.
Yeah.
He had said he felt afraid of being doxxed. He didn't specify by who, which apparently is
Okay.
where.
So see, this is the political and the dark. This is the black ops stuff. Okay, now look. Let me explain what this guy did. This guy is, I think he's got a master. He's not a PhD physicist like I am. He has a master's, I think, in astrophysics and geology or something like that. He's a smart guy, okay? Young man, I guess. Smart guy. And he also did forensic analysis exactly. He doesn't know any theory, really, okay? He did what Paul Hill did. He did a brilliant, because he does know gravitational lensing. He does know some general relativity. He made very detailed photographic, he knows how to do photographic analysis, all that stuff. And he made a convincing case. Number one, it's warp drive. Definitely it's warp drive. It's for the same reasons I said. Independent, I never met this guy. Totally independent. And he also shows from the photographs that there's gravitational lensing there, which I independently also said there's got to be gravitation. All the shape shifting, when they see like the lights, they see like one light and then the light becomes like four lights. That's standard gravity. That's just like what happens in the gravitational lensing of stars, you know, multiple images from the, yeah. So there's a lot of evidence for gravitational lensing, and whether he was told to shut up by the Defense Department or something, it's too close to, who knows, but it's very suspicious that he went offline, because everything he said was confirming my stuff. But he didn't, he said, oh, it's crazy. We don't know quantum gravity. And he just bullshit around about he didn't know about metamaterial. He never mentioned the metamaterial. He never mentioned anything I talk about. He said, oh, we won't know how it works until it's quantum gravity. It's, ER equals EPR, a lot of bull, he hand waved. But his evidence and the way he analyzed the evidence, the empirics, were perfect and in total corroboration of everything I've been saying.
I thought it was intelligent commentary.
I just uploaded, I had a zip file for this. So I just uploaded this into chat. So you can download that. Anybody in the conference can download that right from chat. And that's just the archive of his full website with all of the images and all of that.
Yeah. Okay, any more questions?
Thank you.
Okay, thanks, Carl. Let me go back to, let me go to Adept Monatomic Alchemist. Sir?
I think it's a woman, isn't it?
No, I believe.
Definitely not. Definitely not.
Oh, is that what?
Oh, hi, Bernie.
This guy with long hair.
Yep. Just a hippie with long hair, don't care.
Okay.
I was just wondering your opinion on Walter Russell's work, specifically the cold fusion reactions he claims to have produced in vacuum tubes.
I never heard of the guy. I don't discount cold fusion. The guy you're going to talk to is Brian Josephson, Nobel Prize physicist, Josephson effect, who follows the cold fusion. I have nothing against cold fusion. I'm not following it. But I'll tell you what cold fusion would be good for. Cold fusion would be good if there was a cold fusion battery to power my metamaterials, as a power source, as a battery. A cold fusion battery, that might be very nice.
So I might be able to help you with that and send you a bunch of material that I'm making through electrolysis cold fusion. And it's based off, my research is based off of Isaac Newton's alchemy writings, and then I don't know if you've heard of Mehran Keshi, the Iranian, but he also goes into these monoatomic plasmoids.
I heard,
and
I don't know, but you know what? I'm so involved, and I'm so far behind in reading papers that are directly relevant to what I'm doing that I don't have time for the cold fusion. I'm not saying, but Brian Josephson might. Okay,
Yeah.
so what you do is say, if you want, send it to me. I'll pass it on to him. And there may be a few other people I know. I'm not
Well,
sure.
yeah, let me
But
go back to
Josephson has
Jeremy.
experience.
Let me go back to Jeremy Reese then. Bernie, thank you again, sir. Let me go back to Jeremy and then, okay, Jeremy, sir?
My hand, I didn't have a question. I forgot to lower the hand.
Oh, okay. Sorry about that.
But I do
Um,
think we should get Jack on some of these right wing political. I have connections with Tim Pool. I'm going to see if he can get you on, because it's unfair that these other guys get all this coverage and you don't. So I'm gonna
One of
see
the reasons,
about.
let me tell you. Okay, let me tell you one of the reasons. One of the reasons I was getting along pretty well with Christopher Mellon. In fact, by text and stuff like that. And Christopher Mellon, he was going on Tucker Carlson, one of the shows, and he asked me a question about black holes. He doesn't. I mean, Chris doesn't know anything about physics. I mean, really nothing. I mean, but he's totally confused with black holes. So okay, so I set him straight a little bit on that question right before he went on some television show. Somehow, at some later point in email, he mentioned something. This was during the election, the Trump election, and he said something about Trump, which I didn't like. I was actually a Trump supporter, I'll admit it, and he's obviously he's a Democrat. He's a progressive guy, so that's what caused a falling out. So then Chris Mellon started sending, automatic replies saying, I'm an asshole. Like, I mean, he took it. I mean, here's this guy. He's a Mellon. He's 20 years younger than me. He's the top of his game, and he took offense. He got emotionally involved over a political dispute involving Donald Trump. So that's part of what's going on here now. Okay. Go ahead.
okay, and let me see. So let me ask who else has. Let me see who else has questions. I'm just scrolling through the chat here. And Jack, I want to thank you again for joining us.
Yeah. I'm trying to get back.
Sorry, Tim. Mark Florentino had a question. Do you want to jump in, Mark?
Yeah, Mark, would you like?
I have a lot of questions actually, but I missed the front. Unfortunately, I missed the front part of the video. The first couple 2.5 hours.
Okay.
So it's, what I'd like to know, I guess, basically, is that you mentioned something back here, and I asked a question about what the ring was made of at the bottom of the craft that you were showing a drawing of. The vortex ring. What is that made of exactly? What is the construction?
Well, that's what we want to. It's a what we want to have is a. Wait a minute. Let's see, I got my way back here now. Hang on. Yes. Okay. Let me get into my. I don't know why it's doing. You're talking about this picture.
Yeah.
And let me just do it again. I don't know why it's so thick. Let's see. And let me do page.
Are those superconducting magnetic coils?
No, those are going to be. Wait, I'll explain in a minute. This will be gravity. This here will be cosine. This is in the equations. Cosine theta is greater than 0. And this is going to be cosine greater than 0, and this is going to be anti-gravity. So sorry. Okay, so this is warp drive. This is God.
You're on a number 8 pen if you want to know why the writing's so thick.
Yeah,
So
why is it?
you're on a number 8.
Oh, you saw that there's a number thing? I don't have control. Okay, where'd you see that? Ah,
Yeah.
thank you. Yeah, got it. Okay, next one will be better. So no, these are what these are going to be. These are yeah, okay, quantized magnetic vortex rings. They're vortex rings. You know, they're
And you're calling them vortex rings because the magnetic field is
Yeah,
creating
the
a
magnetic field,
rotation of space.
there's a magnetic field in here. There's a magnetic field, right? And that magnetic field, there's a inside. Let's see, the magnetic field. There's going to be a mu, and the mu is going to be going to zero. The mu is very small, but the S field, the amplification effect, the S field goes as 1 over, but goes as mu zero over mu squared. And then there's going to be a T0, there's going to be a B squared over mu again there, okay?
It's
So
like a type 2 superconductor.
yeah, this is like a type 2 superconductor.
That's correct. That's what I would expect it to be. And I would also expect mu to go to 0.
To what?
And I also expect mu to go to 0. I believe that is
Yeah,
very
yeah, like
important.
going to zero. Okay, but now here's the equation. Einstein's equation. In this case, let me do it right. I'm gonna just do the Newtonian limit, the weak field limit. It's del squared. It's del squared because there's a 1 over c squared here, and there's a 1 over c to the 4th there. So what it is, it turns out it's del squared. This is Newtonian potential. Del squared phi is going to be something like 4 pi g over c squared. And I'm going to have the square root of s times b squared. What's going on? Come on. Well, I don't know why it sometimes does that. B squared over mu. So this is going to go. So what I'm going to have, it's going to go as mu 0 over mu squared. The amplification. I'm going to amplification factor that's in the square of mu. So as mu goes to 0, you know, this, in other words, the coupling strength, let me do that. The coupling of magnetic field to gravity is going to scale as 1 over mu squared. So as mu goes to 0, you know, we're amplifying the coupling of the magnetic field to the gravity field it's making. Okay, that's roughly in this model.
I don't know if I agree with the last statement, but
Well,
you
that's
are on to something. I will say that.
Yeah, well, this is
very much similar to what's, your drawings are very much similar to what's in my book. And I'm just very, very curious.
Okay, have you had any ET, any paranormal high strangeness experience?
I have had, I'm writing another book to explain all the paranormal. Yes,
so
I have a lot of those, but it's so many I could fill a book.
How old are you now?
I was, when they started, I was 20. But it's a long, involved story.
Yeah, but how old are you now? How many years ago?
66.
And 66. Okay, all right. Okay.
Yeah, I'm an old timer.
Yeah, yeah.
Yeah, there's a lot of truth. You're so close on so many things. That's giving me chills.
That's interesting.
Because it's agreeing a lot with the theory of super relativity. There is some nuances that we might not agree on.
Remember, I'm only using Einstein. Einstein. I'm only using very elementary physics, 1916
Just like me.
GR. Okay. Ah,
Well,
okay.
we agree there too. I use even more elementary. I use what in, I have a paper where I unified gravity to electromagnetism and also
Let me
found
tell
the
you about that.
origin of mass, gravity, and inertia.
Okay.
They all
well,
come from the same thing. But
Okay,
that's
well,
another subject.
okay, okay, I'm not doing anything like that. I just want to make it clear the difference between what I do and what you do. What I do,
Well, I like that you're using Einstein.
I'm also using Maxwell.
Yeah, I like that too.
Okay, Maxwell EM. What Einstein, well, okay, so now what Einstein.
I use Maxwell, Einstein.
Okay, all I'm doing is
Lorentz.
this. All I'm doing is this. All I'm doing is this. I'm just saying the gravity field, G mu, the Einstein tensor, is going to be equal to 8 pi G over C to the 4 times this S field times the T mu nu for the EM field. This is the EM field. So Einstein's equation automatically, in a special case, shows how the electromagnetic field is transformed into the gravitational field and vice versa. By the way, it'll go two ways. We can use it for gravity wave detection too.
This equation is very similar to something I was given.
Okay, what do you mean? Well, this is Einstein's equation, except with the
Yeah,
X.
well, I'd love to say more here, but I can't.
Yeah.
Okay.
This is amazing.
Okay,
Okay.
let me just say this. Let me just get the hit so people who are watching. Einstein, 1916. 1916. Let me just say. Let me try to. This I wish Nick Herbert was still here because Nick Herbert, was making a phony argument that I'm saying I'm not using conventional physics. I am using conventional. 1916 is G mu nu equals 8 pi G over C to the 4 T mu nu. In particular, if this is an EM field, this is the, EM creates gravity. This is gravity. And by the way, in most practical applications, matter, even when you put in matter, the electromagnetic field is the dominant field, long range, right?
Yes.
The weak force and nuclear force don't do much. Okay.
No, they're interactions mainly.
Yeah. I mean, they're there, but they're secondary effects.
Secondary, exactly.
Okay, now this is Einstein. Sarfatti, Wanzer, 2020 is basically 8 pi G C to the 4 S. Oops, it goes into that automatically. That's weird. When you press, if I press down too hard, it changes the thickness. That's what it is. That's what I've been doing. Getting to it. So this is all. I should use the Superman symbol.
Yeah, and then after this, actually, I had a quick question as well,
Right,
Jack.
yes. Okay, that's all we do. So that's why I say we're doing minimal. We're only using elementary mainstream physics. This is our only chain putting this in, and for which we have good reasons. We have sound reasons, both experimental and theoretical, for making this move. It's like a chess game, right? We've just made a gambit. We've just changed the strategy in doing a chess game, and we've done this is the Sarfatti Wanzer gambit in this chess game. Okay, so that's it. That's everything comes from there. That's all we have to do to explain everything. We explain everything that the Navy is seeing, and we plus weapons applications. That's what I'm saying. It's elementary mainstream physics, not mysterious.
Yeah. Okay. Well, Mark, thank you again, sir. So, Jack, if I could ask you to elaborate briefly, you mentioned something probably about an hour, probably an hour and a half ago, and to me, I can feel kind of a paradigm shift. But so you had mentioned that these devices would allow a warp drive, obviously, but there would also be some kind of I think you were describing as like a Stargate, right?
Yeah.
The same device. I mean, what kind of capabilities do you think that might provide for UAPs?
Wow. But any a lot of capabilities. Okay, Q in Star Trek. Remember, anybody know? Everybody remember Q in Star Trek? That's the capability. Well, look, if you control the gravitational field with small amounts of energy, control of gravity.
Oh, and William Schramm actually just also asked if UAPs can travel through solids, but I think that's
okay. That's what that gets back. That's that first slide. 5
Yeah.
examples. That's the slide that Louis Elizondo, Harold Putoff always use. Okay, that's the slide that, and there were 5 points, right? I said I could explain points 1,
4. Yeah.
1, 2. There are 4 of the 5. The one I'm not sure of is travel through solid matter, and for that they got to talk to. I mean, I'm not discounting it, but that's Hal Puthoff's shtick. Let him deal with that. Okay, I'm explaining 4 of the 5 is good enough for me. Okay.
Well,
Okay. So, but getting back to the original, look, control of gravity with small amounts of energy, it's time travel. One thing. And that's, they said they came back from the future. Time travel with small amounts of energy. We're talking about time travel technology. Now, there's enough science fiction stuff about what happens with time travel. Okay. Then you have, there are no paradoxes because there's what's called global Novikov loops.
Well, so one of the things I spoke with an Air Force person, this was probably a couple of months ago now at this point,
Yeah.
and one of the things that he had questioned, and when you mentioned the Stargate, it brought this to mind. He'd said, what if these vehicles, what if UAPs just, he said, we've been thinking of them in terms of vehicles like an aircraft, but he said, what if we thought of these almost like a cursor in 3 space, right? The cursor on your Mac.
Yeah. That's the hologram universe. Is the universe, a simulation. Are we living in a simulation? That's all that stuff, right? The thing is this, with metric engineering physics in the physical sense I am talking about, is functionally speaking indistinguishable from a digital simulated universe. And that has to do with EPR, ER. This is qubits, bits.
Okay.
Engineering. They're 2 different. They're 2 sides of the same coin. Anything, yes, it's as though we're living in a computer game, in a video game. Yeah, with metric engineering, functionally speaking, they're equivalent. They're just 2 different ways of describing it. So, and this is this is Lenny Susskind.
Yeah. Well, thank you for
Yeah.
clarifying.
So the answer, tell him, hey, you should tell this guy, get in touch with me. Tell him the answer to that is yes. Both are, they're 2 different, they're dual descriptions. They're complementary, but like quantum mechanics, complementary descriptions of the same reality. Once you can control gravity like that with small amounts of energy, including maybe your mind. See, one of the things Hal Puthoff wanted to do with the mind, the levitating monk in Italy. Nick Herbert's into that too. So the answer is yes. That also accounts for the high strangeness. The paranormal high strangeness dimension to this whole scenario, to my whole world line, my 70 years or more in this quest, in this field, right?
Yeah. No, yeah. Now, I mean, I know when you describe high strangeness, you mean many different things. But
Yeah.
do you think like when I think of that, I'm thinking Hey, I think we're almost at the top of the hour, so I should probably do one more call for questions and see if anybody else. I think Mark had another one. Okay, so let's do Mark, and Mark, go for it, sir. Sorry, that was sorry. Well, yeah, go ahead, Mark. It was actually Bernie that raised his hand, but.
No, go ahead. I was just making a comment about the Stargate technology, which I put into the chat.
Yeah.
Oh, okay.
Yeah, okay, the start, okay, so Matt Visser, okay. The place to look at Matt Visser. Matt Visser archive, ePrint archive. He took the traversable wormholes, holes with the what's called exponential metric. And then he also has papers on warp drive and tractor beams, beam weapons, tractor beam weapon. He doesn't use the word weapons, but he has a picture that has like a weapon. So all these three, Matt Visser is into all three of these applications of the same. G mu nim is 8 pi. G of a c to the 4. He doesn't have the s, T mu nu. Yeah, he doesn't have without the s. So for him to do what he wants to do would not be possible practically because it required too much energy. I've solved the energy problem, okay? But he has all the applications. All these are, you have a basic equation, law of nature, and with different applications. You have like Maxwell's equations. They describe, electrical circuits. They describe antennas, radar. They describe all kinds of things. All different applications, right, of the same laws of nature. So what I'm claiming is that the whole UAP, UFO technology is very simple in principle. All of UFOs.
Okay, sorry about that. So sorry about that, Jack.
Okay.
In the Q&A, we allow people to unmute themselves, but sometimes they hit the button on accident. So let me go to Bernie for one last question. I think we'll probably wrap it up after that. Bernie, do you want to go, sir?
Absolutely. Thank you. My question is.
I wish I could flip and hide.
Okay. Sorry about that. I think those people might be spamming us or something. I'm not sure.
I think so. So my question is, do you see a correlation with all the ancient metaphysics and the development of our conscious understanding of technology now connecting to the ancient knowledge of metaphysics?
It depends what you mean by, what I think is this. Okay, what I think is this. Garden of Eden. Eden is time travel. Time travelers from genetic engineering. Primitive humans to us. Roughly what, 6,000 years ago? Or maybe a little more, I don't know, something like that. Abrupt changes, right? Abrupt change. In other words, an abrupt change in evolution. Time, right? This is interference from the future. I mean, about language appears suddenly. Oh, language. All that stuff, That, I mean, there's no written language. And we're only like, what, 6,000 years old? Roughly speaking. I mean, recorded the use of language and writing and stuff like that. It's like that, right? And I'm claiming that was an abrupt thing. That's evidence of time travel. Also, the Upanishads. I mean, Ezekiel. Ezekiel's vision. All the Star Wars stuff in the Upanishads or the Hindu stuff. There's all kinds of evidence. I mean, the sky gods. Even the. By the way, Muhammad was taken up into a UFO, right? It's in the Quran. I mean, what kind? And the Star of Bethlehem. What's the Star of Bethlehem? It's a UFO, right? It's a primitive minds. So yeah, there is ample evidence, reinterpreting history, ample evidence in the literature, in the art forms, the pictures of UFOs. I mean, we all know. So the answer is, it's pretty obvious. People have been denying what's obvious. We are genetically engineered by the same Tic Tac intelligence that contacted me in 1953. They were here 6,000 years ago. We're being genetically engineered. It's all time travel. And that's a new way of looking at history. So I think I can make a pretty strong case against anybody trying to oppose that idea. Apart from just being a religious zealot and just saying being like the Taliban. The Taliban cut my head off, but
Okay, wonderful. Well, Jack, thank you so much, sir. That's my fault. I changed the settings. I've had people Zoom bombing us, I think. So let me do this. This has been an amazing 4 hours. I want to put, so let me stop sharing real quick. Okay. Yeah, sorry about that. We have an enormous conference here. Let me put this on gallery view. And again, everyone, please give Dr. Jack Sarfatti an enormous hand.
That's okay. I don't need that.
Jack, I genuinely cannot thank you enough. It's
do
amazing.
Some editing. Yeah, do some editing, right? And then
Yes, sir.
The basis, we can go into more details now that people know what to expect.
Okay.
And then to draw, we can have some really serious discussions, and why people like Eric Davis are not trying to engage me in this. They're just trying to pretend I don't exist.
Well, and let me apologize for the interruptions too. I've never had that happen before, where people would come on and unmute themselves repeatedly. And the last person who did it came on twice. It was the same person, same name, twice at once, and they were doing it with 2 different accounts. I don't know. Never had that happen before. But
a lot of idiots. People, are afraid of what they don't understand.
yeah. Well, you're a big name also, so it could be that you're a big name draw. So
yeah. And
okay. Well, so I think everybody. I think that wraps it up for today. So I want to say,
and just I'm Jack Sarfatti at gmail.com. If you have detailed questions,
yeah, absolutely. Well, and then stardrive.org, I think, is the website, and I'll put all of that into the page as well.
Okay. All right.
Okay.
I have checked the Vimeo and YouTube channels.
Wonderful. Well, thank you again, Jack, and thank you to everyone who joined us today.
Okay. Cool. Bye-bye.
Recording.